flight pad, over.
Yeah, do flight come.
Step 1.2 reporting completed. Step 1.2 completed, over.
Thank you. Then we're ready for 1.3. You are okay to turn on electronics in the charger box, over.
This is Pat carrying out step 1.3, turning on Nexø I electronics. This is Pat, electronics is activated, over.
Roger, thank you. Then we'll just need a few minutes to confirm that everything is operational and we are receiving data, over.
This is Pat, we are hanging on, over.
Pat, that's right.
This is Pat, over.
Yeah, you just need to hang on for a couple of minutes. I'm talking on the hand radio right now. It's not a viable solution, so we're rigging up another...
Okay, maybe people here on the stream can tell us if the audio is good now.
Thank you, out.
Could people in the chat please tell us if they can hear the audio before we continue with the stream? Radio noises. Hey, is there sound? Please just say yes if there's sound from me. Okay, nice. Wow, then we're here. A lot of technical issues this day. Today we are launching Nexø I, and we are having today we are going to fire the first bipropellant liquid fuel rocket from Copenhagen Suborbitals. It is with an engine able to put out a thrust of 500 kilos. So we are very proud today to be able to show you this launch, and hopefully we'll continue to have live stream videos for you. The problem here, let's talk about that first. It has been that a video server has broken down on Vostok, and so we miss about 5 of our feeds, and we will also miss telemetry from the rocket, so we won't know how high it went before we interview afterwards. But we will be able to do live interviews with the people on Vostok. That is, for example, Mads Wilson, who will be available for us during these preparations. The checklist has just started, and so let's begin this stream where we will be talking about what Copenhagen Suborbitals is, how the rocket works. We have some experts in the studio, and we will also be able to show you some details about how the different technical items work. We will also keep you updated during, so you will have the latest news here or in the chat. You're more than welcome to ask any questions that you have in the chat. Of course, I won't be able to figure out what you're writing during this stream session here, but we have Rasmus Agtestein on the social media, and he will pick up on any questions that you have for me or the experts in here. Most of the questions, the general things, I will be able to answer, but a lot of the technical stuff I will forward to the experts, and yeah, that will be so. We have also, hi Jan, that is one of the experts, he's coming here. We have, as I said, two guests in the studio. We will have Jørgen Skøtt, who is a pyrotechnician on Copenhagen Suborbitals, and also Bo Brandstrup, who will be, who are the guy who has been wiring up all the technical, technical stuff, and also preparing the CS-Duino, the computer on board.
Pad flight.
This is Pat, over.
So Data and Fido are just confirming that the network is running, so they are carrying out 1.5, stand by.
Standing by, over.
All stations, this is flight. We have just commenced the checklist, and we estimate the launch is 1.5 hours away. Over. Pad flight.
This is Pat, over.
We're still waiting for confirmation from Fido on 1.5, over.
Roger. We're awaiting the situation, over.
Flight, this is Fido. Yeah, come in.
I can confirm that we have contact to the payload, and I have AIS data, so everything looks good up here.
Do you also have a GPS fix? Over.
Yes, that's affirmative. I have a GPS log on the rocket.
Thank you.
Audio is okay? Okay, so we are hopefully back this time. We had to restart a audio server, as I understood it. We have some technical issues. It's summer here in Denmark, and also in the Baltic Sea. It's about 30 degrees outside, and unfortunately our servers, they have heat strokes all the time. So that's unfortunately how it is. We are expecting, of course, as I said earlier, we are expecting to see the ballute deploy in after apogee. That's the top point of the rocket, of the rocket's ascent. We will deploy a ballute, and after the ballute has been deployed, it will stabilize the motion of the rocket as it gets back towards ground with the help of our friend gravity. While when it reaches about 3 kilometers of height, it will deploy a parachute. It's a standard parachute that has been reaped in so that it doesn't break up as it unfolds. When it reaches some height that is predetermined, then the reef will be unfixed, and we will see the full parachute unfold, and then we will have the rocket down again, hopefully safe and sound. Copenhagen Suborbitals, that's the business that we are doing here, is an organization based solely on volunteers work. It's an organization that are building or aiming to build a rocket to send a man into space over the Kármán line 100 kilometers above the ground. We are currently in the process of developing this rocket that we will come to there, but the rockets that we are now is a technology test. We are aiming for, as I said, 6.5 kilometers today with a bipropellant liquid fuel rocket. That is a rocket flying on ethanol and liquid oxygen. So we are testing that technology today. Previous tests, if you have followed that on the live stream on earlier occasions, have shown that we will probably see very good performance from the engine that we are doing a test on today. The engine today is a BPM-5 engine. It's able to put out a thrust of 500 kilos, so we will be able to get up to top speed very, very fast. Also, Copenhagen Suborbitals is based in Copenhagen, and well, that's probably readily available from the name. But Copenhagen Suborbitals is based in Copenhagen, where we have our hangar. The hangar is here. Do you have a picture of the hangar? Picture 34. Okay, my producer just left, so that's it. We have some pictures that will be shown later of our hangar. We have a big hangar here that all the rockets are produced in, but we also have a lot of collaboration with both universities and at least the Danish Technical University, where we can do a lot of stuff, and also producers of different materials are helping us produce, for example, the BPM-5 engine. Today we will be seeing, kan du sætte 34 på? Today we will be seeing this rocket flying for the first time. In a month or so we will be having Nexø II, the Nexø II rocket, where we will be testing another important and very exciting technology, namely the dynamic pressure regulation. That will enable us to fly even higher. But today, har vi den på endnu? Okay, here we are. What you see now is a picture of the hangar seen from above. We have all the cars here. That's from a day where people or the supporters of Copenhagen Suborbitals are able to come and join us in the hangar and see what's going on and how far the development has been. All the cars there, that's from people just visiting us in that muddy day. The conditions today are much better, almost too good, as you can see from all the servers breaking down all the time. But another picture of the hangar is this Cap 36 is a picture that we are especially proud of. That is the producer just put on a picture of himself. Well, that's it. Kan du sætte hap på ISS? Det er 36. Det er den forkerte. Det skal være den med ISS over. Well, we unfortunately also have some technical issues on which pictures we're showing. Hopefully we will not have that later on. Okay, we will
Bad flight. Yeah, we're just having a bit of trouble assigning an IP address to Flemming's computer. Just stand by for 2 minutes, over.
Okay, flight, did you change the radio over?
Yes, we're back at the handheld, over.
It works like a charm.
Roger, we'll stay on this one and you will sit minutes until we get an IP address for Flemming, over.
Just standing by.
people can... Ja, lige nu er der hul igennem ud til, hvad hedder det, vi kan spille en film. Ja,
Skal det være ballute, electronics, flight, rolle, guidance, logistik?
bare tage, hæng lige på. Ja, men det kommer bare senere. Jamen lad os bare tage den.
Hello, my name is Matt Steenfeld, and I am responsible for the development of the parachute system that we are using for this Nexø rocket, and that's my job here. So a quick walkthrough of the parachute system as it will function during the ascent from apogee. We will start out with the ballute being deployed, where the nose cone will be separated from the rocket, and then the ballute will come out and it will basically get the rocket to turn right side up in order to make sure that the rocket is stable. So that will continue until 3 kilometers height, where the ballute will be separated from the rocket and where it will draw out the main parachute bag, which contains obviously the main parachute. And then after 15 seconds the parachute will be fully opened. We will start out by opening it in a reefed stage, where it will only be opened somewhat in the bottom, where we have a line in the circumference of the bottom of the parachute, which will contain the opening a bit. And it has this timer box which will activate from the opening, and which will make sure that it will be contained until for the 15 first seconds. After that, it will cut the line in the bottom circumference and the parachute will open fully up, which will make it go half the speed as before when it ascends to the water again. This is actually a plain standard C9 personal parachute meant for rescue services, and this has been bought basically because that was the cheapest way you could test what is the real purpose of this, which is the reefing system. And the reefing system is basically a method of making sure that the parachute will open in sequence. And the reason we want to do that is that if the parachute opens up completely from the beginning of when it gets into the air, you can risk that it will basically be destroyed because of potential high air speeds and stuff like that. So we want to contain the opening a bit from the beginning, and that is done by this reefing system. The reefing system is, in our first iteration here, is basically just a wire going around the bottom circumference of the parachute, which we have connected to 2 timer boxes. This box contains a timer which is activated once the line is taut, and you can hear the click. So when this is taut, the line is taut, it will count to 15 seconds, which is the time it typically takes for the parachute to slow down to its nominal descent speed. For safety purposes and to be sure that something correctly will happen, we have installed 2 of these boxes which have the same basic purpose, but we just want to be certain that the line will be cut at the right time. This is a prototype in a smaller version of the ballute, and it shows you a little bit easier the content of how the ballute is made up. Basically, it's a balloon-shaped parachute, and it has some air inlets to inflate it, and it has a very important feature here which goes around on the widest part of the balloon shape, which is the burble fence, it's called. And that makes sure that the air leaves the balloon in a way so that it will be more stable in the air. Instead of flapping forward and backward, it will be more stable in the air. So that is a key component of this part.
Okay, and we are back again on the live stream. We will be. You're not supposed to hear anything. You're just supposed to sit there. Okay, we're back again on the live stream. We have Jørgen Skødt with us. Jørgen Skødt, you're a power technician, and you have been with Copenhagen Suborbitals for how long?
Since 2010.
Okay, so 6 years now. What's your favorite? Hvad sker der? Du skal rykke tættere på her. Sorry.
Bad flight.
Sorry, we have focus issues. Okay, so what we're looking at here is the rocket.
Yeah, we seem to have lost uplink to the rocket. We're just debugging.
I hope
Stand
that
by.
you could talk us through the different parts of the rocket.
Yes. Can we have the picture?
Yeah, the picture just lost here. Kan du få billedet på igen? 43. Ja. Er den på igen? Okay. Jeg kan ikke se, når den er på, bare så du ved det. Okay, sorry, we're back again. We have some production issues here. What we're looking at here is the Nexø I rocket in all its glory. How big is it?
Oh, it's 5.6 meters long.
5.6 meters.
Yeah.
So we have quite a big rocket, but is it the biggest rocket that we have performed with yet?
No, we have had larger rockets earlier on, but this is the most advanced.
Okay.
This is the most advanced ever.
Okay, so why is it the most advanced? What does this rocket have?
First of all, it's built in another way that usually we have used. It is built in SolidWorks.
Yeah.
And then we
SolidWorks, that's a CAD program.
Yeah, that's a CAD program. And first of all, and then we have had all the parts cut out.
Jeg sidder lige den her op her. Du er for lav. Gider du at skrue lettere for Jørgen? Derfor klager over, at Jørgen er lav. Sorry.
Okay. I'm too low.
Yeah, sorry.
First of all, it's designed in CAD.
Yeah.
The rocket. And second, it's a lot of the electronic system, which I don't know much about.
No, but that Bo Brandstrup is coming. He will know about that.
That's also developed further than earlier.
Yeah.
And we have a new kind of parachute.
Yeah.
It's called a ballute.
Yeah. A drogue.
Yeah.
Yeah.
And that is one thing. And we have use the parachute when it comes out. It's reefed.
Yeah.
It's opening in two tempi.
Yeah.
And furthermore, we have a guidance system that is more advanced than ever.
Why is it that?
Well, we have learned a lot from Sapphire, which was a tremendous success.
Yeah.
It was first time amateurs had ever done this.
Yeah. That was Sapphire was the one where it had active guidance on it.
Yes,
okay.
Exactly. It had and it used copper fins to control.
Maybe we can bring up number 44. Where we can see the timeline of all the different models of rockets that CS has put out until now. That is the Sapphire here. That is what year?
The timeline.
Yeah, the timeline. You can't look at this one.
Okay,
it's not live. No. So yeah, Jørgen?
Yeah.
Yeah. When was Sapphire from?
Sapphire was from I don't remember the year. It says.
Okay, it doesn't matter. It's a couple of years back,
yeah,
but it was with the active
3
guidance.
years ago, and it was active guided.
Yeah.
And used copper fins.
Yeah. What's the main difference between Sapphire and Nexø?
First of all, it's we use graphite fins this time because it has a longer burn and probably hotter exhaust gas, and we have tried to use copper fins on this engine, and it evaporates.
Actually,
it evaporated, and it was a very beautiful sight.
Yeah.
Yeah, we can see here. This is the can we see it?
Yeah.
Yeah. This is a graphite fin.
So here's the graphite fins.
This is a graphite.
And they are inside the jet.
Yeah, they are positioned like this.
Yeah. So if the jet goes down like this.
Yeah. The
Pad flight.
This is Pat, over.
Step 2.19, open nitrogen purge valve for 10 seconds to confirm operation. Will you carry that out? Over.
This is Pat. Logs requests a feed pressure on the nitrogen line, over.
At 20 bar, over.
This is Pat, 20 bar acknowledged, over. This is Pat, increasing pressure. Please stand by, over.
Standing by, over.
This is Pat. Logs reports 20 bar feed pressure on the nitrogen line, over.
Do you reckon that to be sufficient flow, over?
We expect that the test will show this. We will be carrying it out twice in different configurations. So please proceed according to checklist, and we might redo 2.19, over.
Sorry, when do we want to repeat 219, over?
After. So please proceed to 2.19 and let's try the purge system, over.
All right, we'll enable it. We'll open it. Over.
Du har ikke den
It is open.
Okay, det må se.
Again, over.
The nitrogen line is open. Over. Do you confirm?
We had plenty of nitrogen, over. Please hold. Fly pad, over.
This is fine.
Cool. Okay, now we are fortunately back again in business. We have had some audio issues, but we think that it has been resolved. What we're looking at here is a map of where we are, or the team out in the Baltic Sea is. That they are in the Baltic Sea, just east of Bornholm, about 35 kilometers out. Right now we are in the process of fueling the rocket, so we have some time here to talk about where we are and what this area is. Could you bring up number 46, where we can see the ESD?
Pat, booster is satisfied with step 2.19, over.
All right, then Data and I will carry out 220 and 221. Stand by.
Pat, standing by, over.
All right, Pat, Dana and I, we have completed step 220, 221. Over.
This is Pat, acknowledge step 2.20 and 21, over.
Pat flight. step 222. Charger box video power is set to off, is that correct? Over.
This is Pat, I can confirm video power is turned off. Over.
Roger. Then you'll go for 223, release the and remove the clamps around the rocket. Over.
This is Pat, carrying out step 2.23, please hold. Over.
Shit. Jeg ved ikke, om jeg...
Okay, and the server's back up. Ah, damn it! It's a tough day to be a rocket enthusiast.
It's a hot day.
Of course, we're terribly sorry about all these issues. What we're looking at is the ESD 139.
Yes.
That's the test area.
And that's actually it's out in international water.
Yeah.
Yeah. So the Danish law doesn't apply to this area.
We found a loophole.
There's a kind of it's a loophole, but of course we have to be careful. There's a lot of other people out there. There are aeroplanes and there are other traffickers like fishing boats and so on.
And fish.
And fish, yes.
Also fish.
Whales, maybe? I don't know, actually. But it's an area that is used by NATO to perform different exercises.
This takes 30 seconds. Over.
We are allowed to use this area.
Yeah.
We don't have to ask permission. Because it's actually it's an international area.
We just have to arrange with the
we
right
have to
authorities.
arrange with. Of course, we discuss it with the authorities in it's actually in Sweden and in Denmark, because to prevent people from getting hurt, we have some rules about telling people, how we tell people that in this area we have missile launch.
Okay, so that's an actual official thing here.
Yeah,
we
that's
have a
an
missile launch.
official thing.
To the right in the image, you will be able to see the Jorder ship. That's the home defense.
Yeah, that's a home defense vessel.
Is it on an exercise today, or
it's a kind of exercise. It is their job to take care of people and ask the fishing boats to leave the area where it is actually dangerous to be in.
Yeah.
And they are patrolling around and
keeping people out of harm's way.
Keeping people away. Yeah.
We have other boats in this pretty large fleet. Are we out of audio again? No. Okay.
It's a rather large fleet. Actually, it's larger than you see on the picture.
Yeah, we have also. If we take slide 48. We have a picture of Sputnik.
Yeah.
And Sputnik is the launch pad.
It's a launch pad and it's a catamaran.
It's a
motorized catamaran with 2 motors.
Yeah.
And
when was that built?
That was built back in 2010.
Okay.
Yeah, and built for one purpose, that was to launch Heat 1X.
Okay. So to get through that loophole, that is to fire from launch from international waters, you had to build a mobile launch platform.
Exactly, and in the beginning, we didn't have motors in it.
Yeah.
That was seemed a bit difficult to move around with a ship with no motors.
So it was dragged.
So then we installed motors, and in 2011 we sailed out.
What's the top speed of that
pile
of iron?
It's less than walking speed, I think. It's it's about walking speed.
Walking speed.
Yeah.
So the time to Bornholm, how far? How long?
36 hours.
36 hours.
Yeah, and
there's not much space on Sputnik for relaxing or staying out of the wind. So good weather conditions, I guess, is very important.
The funny thing, it's difficult to see, but if you look at the platform, when people are walking around on it, when we have a live picture,
can we have the live picture?
Could we have a live picture here? They're actually walking around on. They're looking through holes directly down to the sea.
Yeah.
And they can see the waves, and when we have high waves, they actually go up through the down to the. In Danish, it's called elephant rest.
Okay, it's not important.
No, it's not so important. But it's not so comfortable to live on. But
okay, so if you sleep in a sleeping bag, you will get wet on your back.
Yes, you will.
Okay. Okay, so and another ship in the fleet is Vostok. That's the command central.
Yeah.
That's picture 49. If we can have that. Vostok is the ship that has caused us much headache in the past few days. There has been a lot of problems with the engine and a lot of problems with the leak.
There's a lot of small problems because it's an old lady from 69, and it has had several owners who didn't always know how to handle her.
Okay.
It's a very special ship because it's completely made in aluminum.
Okay.
And it's very compact. It is almost impossible to sink.
So and it is also bought for the purpose of recovering the rocket. Its back end can open up.
The back end can open up. And you can drag in the rocket there. Yeah.
Okay, if we bring up another picture here we would like to see is number 51. That is a real picture of Jordi, where you can see that there's a lot of folks on board also helping us out here, both people from Copenhagen Suborbitals and also from the Home Defense.
Yes.
And a lot of thanks goes out to those guys who We'll have a short break. Sorry.
Fuel vent open. Pat, we are ready for step 3.5. You are go for commence fueling. Over.
Is extremely hot, so we are sitting in a small caravan with the servers, and that might not be the best idea.
Oh,
yeah.
We might want to ventilate the cupboard with the servers.
Yeah, and now also the light is also breaking down now. Wow, it's kind of a discotheque in here.
Yep.
Yeah, it's actually pretty nice. So maybe we should, while we're waiting, put up the video feed from the launch pad. Is that possible?
Maybe.
Okay, and the fuel loading has been put on hold as the pad leader out there is looking into a problem with the telemetry towards the rocket from, I guess it's Vostok. Is it Vostok that receives the signals?
Yes, the telemetry is received on the front of Vostok. There's an antenna tower mounted there, which is pointed at the rocket.
Okay.
So they seem to have lost the connection from the rocket to Vostok.
Okay, could that also be a heat issue?
No, that shouldn't be the case.
Okay. Why is that?
The computers dealing with the telemetry is in a separate rack, so they should be trundling happily along, no matter how hot it is for the servers that are handling stream and all those kinds of things.
Okay, so it's not like in here where things kind of die all around us.
No, it shouldn't be.
Okay.
It shouldn't be.
We is the picture server up yet? Can we have picture number 53? No. I guess not. So we are right now looking at the Sputnik. They are moving right now. Why are they moving?
I can't tell you why.
They
may have been adrift on purpose.
Okay.
Of course, and may have drifted from the intended position.
Oh, because of the
delays. So they are now returning to the position they want to be at.
Okay.
For
being
for
safely within the ESD 139.
Yes.
Of course, this they will stop before launch and evacuate all personnel on board in different.
Of course.
Yeah, someone is saying that they are stealing Sputnik. They're revolting.
I don't think so.
Oh, I guess this is what the internet is made for. People come doing stupid comments that are hilarious. I love it. Okay, right now we can't actually see any of all the things that we have brought in here today, but we are able to talk about the telemetry that we have available on the rockets. We are dealing here with a system that you have made yourself.
Well, we have made.
Yeah, you. Yeah, of course.
I have just made the circuit boards for it.
Yeah, so you designed your own circuit boards for the purpose of building computers to Nexø I.
Yes, we did that in order to have a more ruggedized computer platform. It is based on the Arduino platform.
So it's an Arduino in the Nexø I.
It's more or less an Arduino with a lot of add-ons.
Okay, what can you tell us about what is an Arduino?
An Arduino is a computer designed for hobby use. It's designed for very rapid prototyping. Enter a few lines of codes in the C language and download your code to the Arduino board, and you are up and running with like blinking a LED and making sounds in a small speaker and so on.
Very easy and readily available for.
It is. It's very widely used by hobbyists to have a quick start at using computers for controlling purposes.
Okay, and maybe we forgot to introduce you. That's in all the haste. This is Bo Brandstrup. He is a computer and technician for all the computers on the on board the Nexø I and also past rockets and hopefully also future rockets.
I hope so too.
Are we building? Are you building right now on Nexø II? The computer for Nexø II?
Not intensively. We're waiting for the results from the Nexø I rocket.
So we are waiting for the data from this launch. What's the main difference then between an Arduino, that was this commercially available computer that it is based on, and then the CSduino that this platform that you have developed is called?
Well, mainly it's we have made it more mechanically stable and ruggedized. I have the circuit board here. I can show you here.
Yeah, no, you can't because there's no image of us.
There's no image yet.
Peter, is there any chance we can have an image of us in here?
Never mind. The Arduino is a small board. It's the size of a playing card, something like that.
Okay.
What we have is maybe the size of 4 playing cards put together. And we have made it a lot more ruggedized to fit it into the environment we have on board a rocket.
Is that physical stresses or is it?
It's vibrations. Mostly those.
How do you cope with vibrations? I guess they are pretty intense on a rocket going supersonic.
We are simply mounting it with a lot more screws than the normal hobbyist version of the Arduino.
Yeah, and we are going to have a short break right now. Asa? Okay, so we are back now. Right now we we have been told that the problem with the telemetry has been resolved, and we are continuing on Nexø I preparations with the checklists. We were talking before about the computer and how it was different, and CS-Duino was different from an Arduino. You said it was ruggedized, so it would be able to sustain all the physical problems. Is there more than physical problems that shaking and all that could pose a problem on such a computer?
No, the vibration is the main.
That's the main issue.
Main issue, if there are any.
Okay, so so it's on the larger computers that it could pose a problem with cold, or is that?
We have not experienced that. We are. We of course we put the computer in a box, inside a box, and even the one in the motor compartment, the engine compartment, where it is very cold, just below the liquid oxygen tank. We have a thermometer mounted, or it is built inside the processor of the computer, and the coldest we have had, even though the outside is there's frost and ice generating on all the metal parts, and the lowest temperature we have measured inside the box is around -10
okay, so it
centigrade.
poses no issue for...
That should be no issue at all.
Okay, so there's what kind of design... oh yeah, we have the stream on now, so you can actually show the CS-Duino now to the camera. That's
put up the board.
Maybe a bit closer here, so we can see it. Is it the other way around, or is it on both sides?
This is the front side.
You have to
we have a
put it up here, I guess.
Oh, okay.
Yeah. So maybe you can see it here. That's the CS-Duino board that you have developed.
Yes, it's based on the normal Arduino. We have, of course, added all the extra interfaces that we expect to use. We have added those onto the circuit board.
Yeah.
So we don't have to put piggyback or shield boards onto the computer like you do on original Arduino.
Why would you like to avoid that?
That is because of the mechanical issues with the vibrations. The shields are connected to the original Arduino with connectors.
Yeah.
And we avoid those by integrating them on the board.
Okay.
So that would not give us connector issues.
Is it one computer that are controlling everything?
It's one type of computer, but we have 4 computers in all in the rocket.
Are there any backup computers in the machine? If one breaks down, does everything break down then?
Yes, there's no redundancy built in for one specific task. The only redundancy we have is in the radio system, but that is mandated because we have 2 antennas, one on each side of the rocket.
Yeah.
And as the rocket maybe rolls around its axis, then the signal will disappear for the receiver. So we have to have 2 radio channels operating at the same time.
How do you take care of that? Because if it's rotating all the time and it's rotating fast, is that a problem for receiving data?
Not as long as we have 2 radio channels operating simultaneously.
Okay, then it's
then we have full coverage.
Okay, it does not interfere with itself.
No,
okay.
It does not.
Cool. So why did you where are the computers placed on the rocket?
We have 2 positions for computers. We have an engine controller, which is positioned in the engine compartment, of course.
Yeah.
This computer reads all the sensors associated with the engine and the tanks, pressure sensors and thermometers for those. And then we have a section of the rocket which we call the avionics bay. That's on top of the fuel tank, below the parachute compartment. And up here we have 3 computers. One is the guidance and navigation computer, which controls the rudders in the bottom of the rocket and steers it through the air. And the last 2 computers are the radio computers. They are identical and have the same exactly the same tasks.
And that was because
that we have to have 2 to have full coverage, radio coverage
during rotation.
Yeah.
Okay. So where are the telemetry that you get from the rocket? What kind of data do you collect?
We get a lot of engine parameters down. Engine data like chamber pressure, temperature of the liquid oxygen, temperature of the fuel.
Why is the temperature of liquid oxygen important? Just to check if it's there?
We just check it. We have room for the data, so we just take them down. It would be silly not to.
Okay, data file, yeah.
And then we have the pressures for also for the LOX and the fuel.
Okay.
And we have temperature and pressure for each of the tanks that we get down in the telemetry. We also get guidance navigation data. The guidance computer tells the telemetry system where it think that it is. So we get all the data that is generated for the guidance and navigation, and then we get a GPS position.
So we can recover it after launch.
Both that, and we have a second opinion, so to speak, on where is the rocket.
Does it also is it able to put on a position in the height as well?
Yes, the GPS is.
That's also altitude.
Yeah, altitude and position.
Okay, how precise is altitude? Is that as precise as on ground?
Yes, that's the same as moving around on the ground.
Okay, so
that shouldn't suffer from that at all. And also we have a bit of data from the radios themselves, how they are, how they see the world. They, for instance, they monitor the battery voltages on the rocket, and,
okay.
and tells us that.
Why? How is now they're fueling the tanks of Nexø I? Right now we are kind of blinded because all streams are not here for us to see, but. Right now they are fueling with liquid oxygen, and they are fueling with ethanol. What do after they have fueled the right amount, they also pressurize the fuel?
Yes.
Why do they do that?
That's the way to get the fuel and the oxidizers from the tanks, out of the tanks, and into the motor.
Yeah, we have. We should have shown you a nice drawing by Carsten Brandt, who is also a member of. Are we able to show PNGs now? Oh, that's so nice. Now we are talking. We need to show you. We need to show you number 54. It's just because we can't see in here what we are looking at. Here's a nice drawing of the Nexø I rocket that has been opened up. And if we can have number 56. Number 56, then we have a closer look towards the fuel tank in here.
Yes.
And so this is the fuel tank for fuel. That's ethanol in there. And
yes, it's a mixture of ethanol and water. So 25% water and 75% ethanol.
Why is the water inside it? Why not?
The water is added to aid the cooling process, so that the fuel acts as a cooling liquid for the engine around the combustion chamber.
Okay, so there's also in the fuel tank you also see what is called anti-vortex baffle in the bottom. That's the thing in the bottom of the fuel tank that looks like a piece of cheese, systematic piece of cheese at least. Why is that? What is the role of that piece of metal?
It's partly to counter sloshing of the fuel, and also to counter the generation of a vortex when the fuel is evacuated from the tank through a small hole in the bottom of the tank.
Okay, and to viewers out there, if you are able to, we have some troubles communicating in here. If you're able to put in updates in the chat, that would be very much appreciated. We are sorry that we're not able to get it right now directly, but we will update you as soon as we can. The fuel loading has begun, we are told.
Yes.
So they are right now fueling the tanks. Is that they start with ethanol or liquid oxygen?
They start with the ethanol, which is the fuel.
Yeah. Why is that? Why not liquid oxygen first?
Because the liquid oxygen is very cold. It's cryogenic.
Yeah.
It's minus 183 degrees centigrade. And as soon as the liquid oxygen is put into the tank, it will start to boil.
Yeah.
Because of the tank material, the tank walls being much warmer than the liquid oxygen. And after a period of time, the material, the walls of the tank will have cooled to the temperature of the liquid oxygen, but it will still evaporate in
so it will lose heat
on a fast rate. So we will like to have the liquid oxygen in the rocket tank for as short a time as possible.
Okay, we have something called a burst disk with us here that's related to the liquid oxygen tank, and that is in picture number 57.
Yes, there's a burst disk for each tank. It's a safety measure to avoid the tank rupturing if the pressure inside builds up higher than the tank is designed for.
Peter, maybe we can have a view on us here, because we actually have the burst disk with us here. We have it here as an example of burst disks that has been. Are we on? Yeah, here we are. This disk here, that's put on the liquid oxygen tank.
Yeah, on both tanks.
On both tanks, also the ethanol tank.
Yes, because it's the last line of defense, so to speak, against an exploding tank if the pressure gets too high.
Yeah.
So it's what we find to be a mandatory safety measure to install on a
and
tank.
the thickness of this is like kind of twice the thickness of a soda can or something like that.
Yeah, it's not much thicker than a sheet of paper.
What kind of pressures can this sheet here withstand?
This one is, if I recall correctly, it's designed to burst at 27 bars.
27 bars, and that's what have happened here in one of the tests a couple of years ago, a engine test here at Refshaløen, not at Bornholm. Actually, a burst disc blew up. So, what kind of thing could happen if it was not just the burst disc here?
If the burst disc wasn't there and didn't rupture at the time at the pressure for which it is designed, then the worst that could happen would be that the tank would rupture instead.
Okay, and that's
a catastrophic failure, which you would very much
like to avoid. Also, when you are on the boat, if we can go back to Sputnik, you can see that they are working pretty close to Sputnik while they are tanking and also while they are LOX fueling it.
Yes.
So
but you have to remember that while there are people on the platform, the tanks are not pressurized.
Okay, so they are just fueling up,
yes,
and then they are pressurizing afterwards.
Yes.
Okay.
While they are fueling the tanks from the bottom.
Yeah.
And while they are fueling, a ventilation valve in the top is left open.
Yeah.
So that the air escapes, the air atop of the fuel or the liquid oxygen escapes the tank as they are filling it up. So no pressure will build up.
Okay.
That's an important safety measure.
Okay. And and you have to put on extra pressure, and that was because you wanted to press in the liquid oxygen and the fuel into the rocket engine.
Yes.
And the BMP-5 engine, we have a picture of that in picture number 7. Maybe we can bring up picture number 7. You will have to look over here because we don't see the right stream here. It's composed of like 2 shells inside each other. You can see it up here.
It's up there.
Yeah.
Yep. There's an inner tube which is really the combustion chamber, which ends in the nozzle on the right hand side of the screen. And around the tube, which is the combustion chamber, we have an outer shell, and the fuel is running between these 2 tubes.
Okay,
to cool the combustion chamber.
Maybe we should say that on the right, if it's not obvious, it's a cut open version of the same thing that is on the left here. So we have to the left, the leftmost part of the engine, we have a LOX inlet. What it's like a shower inside the engine.
Yes,
why is that necessary?
The injector is responsible for injecting the liquid oxygen and the fuel in jets, small jets, that will these 2 jets for like a jet of fuel and a jet of liquid oxygen
to mix them as much
as
possible.
They will hit each other, and then they will atomize and mix.
Okay.
And that is at this time it will combust and then.
Okay, and before it hits the injector, the liquid oxygen, is that also flowing through that shell outside the engine, or is it only the?
It is only the fuel that is used as a coolant.
And that was the ethanol plus water, so it was 25% water, 75% ethanol that's flowing through there and having the effect to effectively cooling the engine. Why is it necessary to cool a rocket engine?
Because otherwise the chamber wall would simply melt. The temperature inside the combustion chamber is several thousand degrees centigrade, and much hotter than the iron that makes up the walls are able to withstand.
Yeah.
So the outside of the chamber walls is held at about 45 to 60 degrees centigrade, and that is because
during
of the
fuel burn.
During the burn, that is because of the fuel removing the heat from the combustion chamber wall, and
so the fuel must also come hot into the injector.
Yes, it will be hotter, but only at around 45 degrees.
Okay, so it's no huge effect for the burn efficiency.
No, that's
okay.
There's no effect on that.
Okay, okay. We talked about having the pressure put on the fuel and the liquid oxygen, and we also talked about that that was provided by liquid nitrogen and liquid helium. Was that true?
I think we are using for the rocket. We are using helium for both.
Helium for both. So it's only when we are testing out here in Copenhagen that it's liquid nitrogen we use. Okay. What happens during the burn of the rocket? When the rocket uses the fuel, then the gas that pressurizes the liquid oxygen and the fuel must somehow expand.
Yes, it expands and it also cools.
Okay.
So
so it's losing pressure.
The pressure will fall.
Yeah.
During the burn, it will start at about 16 bars, if I'm not mistaken, and then it'll decrease during the burn to almost nothing.
Okay, so that's one of the things that we are testing right now. That's the thing here. The technique is used is called pressure blowdown.
Yes.
And I think for the next rocket, the Nexø II, that's DPR. Could you talk about that?
Yeah, that's DPR stands for dynamic pressure regulation. Instead of having just the amount of helium put inside the fuel or the LOX tank,
yeah,
we have a separate pressure container.
So it's another tank.
Yes, it's it looks a bit like a scuba tank.
Okay.
But it's pressurized to around just shy of 200 bars.
200 bars. So there's a lot of gas in there.
Yes, and the way it is working is that the engine controller will monitor the pressure inside the tank and will use the gas inside the high pressure tank,
yeah,
to add extra gas to the tank during the burn.
Okay, so it keeps up the pressure.
To keep the pressure stable at one value that we aim for.
Okay.
And then, of course, at the end of the burn, the high pressure gas will be exhausted and the pressure will fall. But we will be able to maintain the correct and the optimum pressure in the engine for a much longer time than during the simple pressure blowdown method.
Okay. We have a quick announcement that's not that rocket related, but we go to great lengths for our supporters, and one of our supporters that is in picture 39. He's called Richard. He asked us if we could ask him, or ask his girlfriend if he wanted to marry her. And so this has been sent on, this message. I hope you're seeing this, Richard. Otherwise, this is yeah. And you told us that you would be able to tell us if the answer was yes or no. So right now we could simulate it. Should we that? No, we shouldn't. You have too much beard. Back in business. Bye, Richard, and thank you for supporting us. Both Richard and Julie is also on the Nexø I rockets as part of the small portraits that is on the Nexø I rockets with loyal supporters. Okay, so we are back to the rocket. Right now they are not pressurizing, but only tanking.
Yes.
Are there any things that we should be looking for? Who is on the platform? Is there any signs there of how far they are?
No, we can't tell from the pictures that I can see, at least.
Oh, it's also very much a green picture that we have.
Yes,
It's better on your stream, fortunately.
Yes,
That's the right way around.
It's hard to see because everything is inside pressure pipes, so we can't see what's going on.
Okay, so how do we have any information on updates on how we are? Could someone say in the chat if there's any new updates here? We are loading logs, it seems. Thank you. That is very nice of you. Kus Focus. I don't know what his name is, but thank you. Well, that is his name. Okay, and back to the rocket. We are looking at this rocket. Let's have picture number 55 here. Can we put on picture 55? Thank you. Here we see, you have to look up here again, at least until it breaks down. We have a close-up of the nose cone and the tip of the rocket.
Yes.
Could you talk us through why is it necessary to have this nose cone and parachute in the nose?
Well, we have inside the nose cone we have gas generators, and we have the ballute.
What does the gas generators do?
The gas generators is the same kind that you have installed in a normal airbag in a normal car.
Yeah.
We are using to have enough gas generated. We use the gas generators to separate the nose cone from the parachute compartment.
So it's a controlled explosion, or what is it?
It's electrically controlled, and it will happen just as when you as when an airbag in a car goes off.
Maybe we can have number 33, where we can see the deployment sequence for the parachutes. Have you been part of any of the coding here?
No, I'm happily
without
avoiding any coding.
Okay, but you have been wiring up everything for the ballute and the.
Yes, that's part of my job to install the wiring for those also.
And we have this box here. Maybe we can put us back on portrait videos. You can have it here.
Yep.
This is the controller box that Mads Stenfat also showed you in early on in the video, but because we are a bit unsure of what has been shown and what has not been shown, we will show you again. This is what is it? This box? What does
this is what we call the parachute timer box. The parachute will be evacuated from the parachute compartment, and then when it unfolds, it will be what parachute is called reefed. There's a line going around the circumference of the bottom of the parachute, which holds it partly closed, so only 50% of the area is normally open. In the bottom is opened.
Yep.
So the parachute will not be as effective during this phase. So the stresses on the rocket and the
this is only for the parachute. The ballute itself, what does happen with that?
The ballute is pushed out of the nose cone, and that one will inflate by its own.
Yeah.
On its own. There are pockets on the side of the ballute. I forgot to bring one here, but I have a small demo model. and the air flows into the ballute through these openings and inflate it, so it will stabilize the flight.
Maybe we can bring up number 33 again, where we can see the ballute actually, where we can also see what you're talking about here. We have number 33. Yeah, here it is.
Yep.
There you can see what we're talking about. The air is streaming up along the side of the ballute,
yep.
inflating it. So it acts like a kind of sort of partly a balloon and partly a parachute.
Yes, it's meant to stabilize the descent of the rocket in the first few.
How does it measure the height? I guess it's height timed. This cutoff.
The timer for all the deployment of the ballute is determined by a time after the apogee is
so that's
detected.
The highest point.
The highest point, and a set time.
Okay.
And that determines when the ballute will be deployed.
Okay. And then after a while, then the ballute is cut off, and then the parachute comes out, and
yes.
The reefing and all that. How high up are the parachute deployed?
If I remember correctly, the main parachute is deployed at around 3,000 meters of altitude.
Okay. So and then it will float down, hopefully
nice
like
and
planned.
slow.
Yeah. Are there any examples of things going wrong there? I seem to remember a less tower test where things didn't go exactly as planned.
Yes, up until now, every time that we have deployed a main parachute, we have it. Well, it has happened at a time where the rocket or the less tower in one of the cases was traveling far too fast for the parachute to survive the stresses on it. So on Heat 1X, the parachute was deployed at above when the rocket was traveling at above Mach 1. Okay. So the parachute was, of course, torn to pieces.
Yeah, and we will have a short break now. Maybe we can bring back the live stream of Sputnik.
No, it's not so good. So
okay.
We're going to have a break for about 10 minutes, providing a video.
Okay, we're going to have a short break now. We have problems with the live feed again, but it will be resolved shortly, and we will bring up a video that is has been pre-recorded, a documentary, and it's coming up right now.
This is the Nexø I rocket at its current state of development, and it is the first liquid-fueled biprop rocket of Copenhagen Suborbitals, and only the second one ever attempted in Denmark. It should be considered, shall we say, the light version of the Nexø class series of rockets that we're going to do here at Copenhagen Suborbitals. It's going to be using the blowdown operating mode, meaning that we're going to top up the tank pressures with helium, and then allow the tanks to deplete with the helium expanding directly in the tanks. So the DPR system will not be available on Nexø I, it will only be on Nexø II and forward. And this means, of course, that Nexø I won't get to the same level of altitudes as Nexø II will, but in essence the altitude is insignificant in terms of of Nexø I, as this is more a, shall we say, a technical test of the different systems that one has to master to do biprop rocket systems. So we will be looking much more for the performance of the individual subcomponents in the rocket and the overall design as such to weed out any, shall we say, misdemeanors or non-conformities in the design and optimize that towards Nexø II. Also, one should always keep in mind that Nexø I and Nexø II are part of the roadmap towards the Copenhagen Suborbitals Spica rocket. And the Spica rocket will be the full-scale manned vehicle. In that sense, Nexø I and II aim to demonstrate and familiarize all the people here at Copenhagen Suborbitals with the technologies required to develop and fly a Spica class rocket, which is a much, much larger vehicle than this, of course. But the advantage of this step, or intermediate step, is that all the techniques applied, they double to the Spica class rockets. So what we develop and test on Nexø is the stepping stone required to do Spica in the coming years.
Now, compared to its predecessor Sapphire, Nexø I is about the same length. It is 30 centimeter diameter, where Sapphire was 22. It is slightly heavier. It is not a much bigger rocket. We also don't expect it to fly faster or higher. So the change is all under the hood. Importantly, Nexø I flies our first bi-liquid engine. And we're switching to bi-liquid, though this is a major technology step, because bi-liquid has shown to be more scalable. So if we can make bi-liquid work and fly in this size, we have a design that can be scaled to a bigger rocket, whereas the hybrid motors are notoriously difficult to scale to bigger size.
My name is Thomas, and I am supposedly the project lead on the Nexø rocket. Now, fortunately, the crew working on the Nexø rocket they are so self-propelled that that my job has been very, very easy. So my major contributions has more or less been calculations and the initial overall design, and then purchasing stuff for the Nexø rocket. I'm not myself a metal worker, so I've not been working on it myself. And fortunately, the crew is very dedicated and working very hard on it.
Hello, my name is Jacob Larsen. I've been doing particularly two things with this Nexø rocket and the launch. The first of all is that I've been putting together several of the BPM-5 engines we're using to propel the Nexø rockets, trying to learn how to best build them and how to improve the building as I went from one prototype to another. The second thing is that I'm a co-designer on the Nexø rocket, the mechanical airframe from the avionics section and all the way down to the exhaust nozzle. What I'm particularly fond of already is this entirely new design procedure we've been using for the Nexø rockets, which is basically a modular, compartmentalized set of sections which you can bolt together and pull apart as you wish.
I'm Jonas Bjarnø, and I'm the technical advisor on the Nexø I project. And I've had the pleasure of doing the initial dimensioning and trajectory and performance calculations for the Nexø I.
My name is Flemming Nybo. I work with guidance, navigation and control, which are the fancy terms for trying to make the rocket fly straight up. So, as you may know, we have had a jet vane that has survived a static test successfully several times. So we now know that Nexø I can be steered by jet vanes like its predecessor Sapphire. So as such, the navigation and control system architecture will be identical to Sapphire, and the core of the control system can actually be reused. There are also some changes. Besides the new jet vanes, the control system must be adapted to the physical parameters of a different rocket. That is, its mass, its inertial moments, and importantly how these numbers progress as it uses its fuel during the burn. Also, the system must be tuned for the specific aerodynamics of the rocket, and the aerodynamics of Nexø I have been modeled by Jonas Bjarnø, and the parameters from this work will be added into the control system. Also, we are flying with an analog devices eye sensor IMU. Sapphire also did that and flew with what I believe was the best MEMS IMU available for the purpose at the time. But since the product line has progressed since then, we now have the luxury of a slightly better performing eye sensor IMU. So we expect to get a little tighter navigation performance without any extra effort on our side.
My name is Jesper, and I made this avionics section for the rocket, Nexø rocket. This is the part of the rocket where all the electronics and control equipment are placed. The GPS, the radio, and all communication for the rocket.
Hello, my name is Christian, and I'm the chairman of Copenhagen Suborbitals. For the Nexø project, I have mostly been a coordinator. I've been leading our weekly meetings, and my main contribution is to make everybody work together, figure out who is in need of extra help or extra resources, and have a look at the economy, making sure that the money will be well spent and that we will be spending the last kroner at the last day of the project.
Hiya, my name is Lily, and I mainly work on the turning lathe as far as the production is concerned. And for the Nexø I rocket, I've been working on the production of the dome and the alloy for rolls, which is what you weld on the tanks in order to be able to fit both the stainless steel and the aluminum together. And right now I'm working on the flange for the Nexø II rocket. So that's what I'm doing at the minute.
My name is Martin, and I have been designing a small contraption that links the electrical motor that controls the valve with the main valves for either LOX or fuel.
My name is Bo Brandstrup. I am responsible for the wiring and cable harness in the Nexø rockets. The cable harness is going from the avionics bay at the top of the tanks, traveling in our cable channel all the way down to the engine compartment of the rocket, where it connects the avionics to the engine control and the rudder servos. I'm also responsible for the cable harness inside the avionics bay, which connects the different modules of the rocket, batteries and the power supply and our guidance computer and our radio. On top of that, I also have assembled the CS Arduino boards and defined all the cabling inside the boxes for the modules.
Hello, my name is Stefan Eisenknappel. I am an intern here at Copenhagen Suborbitals, and I help the guys wherever they need me. And actually right now I am working on the baffles, bending the baffles for the rocket. It's like the shell, and looking if all the holes are lined up, and helping the guys with assembling. Also I am doing welding, so I was turning some fittings on the lathe, which goes to the LOX tank, and I'm also welding custom-made fittings, so I just weld them together. And well, that's what I'm doing, and I'm happy to be here.
My name is Rune Hensel. I have been doing the design of the nose cone, which is actually what we can see right here, in the process of being made. And then I have been doing all the LOX certification and cleaning of LOX parts that are in contact with LOX.
Hi, my name is Morten. I'm a member of the board in Copenhagen Suborbitals. And on the Nexø project, I have been doing what I usually do in Copenhagen Suborbitals. That means I have been running the logistics and the purchasing department, making sure that we get all we need at the right moment. I have been ordering the tanks for the rocket from a subcontractor and making sure that they actually delivered what we were supposed to get.
I'm Peter Mortensen. I am building a video transmitter for Copenhagen Suborbital that's going to fly on the Nexø rocket. The project was started by Alex, and I'm finishing the transmitter part, so we can try to transmit DVB-T down from the rocket down to the platform.
My name is Peter Meinke. I have made the most of the welding in the Nexø rocket, the pipelines. In the test stand I have developed the mount for the tanks, the LOX tank, and the most of the welding of the setup for the test jet vane. Also the jet vanes mount for the Nexø rocket. That is the design of the rocket and the design of the test stand also been involved with.
Hi, my name is Flemming Rasmussen. I am a software engineer of profession. So that's the reason here in Copenhagen Suborbitals I mainly do mechanical design and manufacturing. I have the lucky position that I work in a company where I have access to 3-axis CNC milling, and thus a lot of tasks concerning that is coming my way. As an example, for the Nexø, I have manufactured and partly also developed a lot of the parts concerning the thrust vector system. Here we have the graphite jet vanes. Here we have the vane bearings, which I've all milled out, and together they form this beautiful piece of equipment that hopefully will point the Nexø rocket towards the skies. Unfortunately, on this project, I have not had too much time because my other job takes up a lot. So basically basically that's what I've been doing, but hopefully I'll be back for the Spica with more inputs.
My name is Peter Scott. I'm involved with a number of different parts of the rocket. First, I've written the software for the engine controller that we use to control the engine and all the sensors and servos around it. Secondly, I've designed the telemetry radio system, which we use for getting telemetry from the rocket and down to Earth, and also getting commands from Earth up to the rocket while it's flying. Third, I'm involved in the data transmission system for our video live stream system, that is getting the video data from the ships and all the way back to shore and onto our mixing system. And last, I'm involved in doing maintenance on Vostok, our command ship.
Well, welcome to the OB1 here at Copenhagen Suborbitals. This is where we are actually mixing the live stream. My name is Peter Mærsk Møller, and I have been helping creating this system we have here. We have a couple of screens. We have a mosaic screen that we usually also send out into the live stream, and we have a premix and a postmix. The premix and the mosaic is taking place, being mixed in the Baltic Sea, and we control it here from Copenhagen. The postmix, where we add text and commentators, audio, we mix here in Copenhagen, and then we send it to YouTube Live. We have created a little system where we can control the mixers in the Baltic Sea, in the middle of the Baltic Sea, and we control both the audio and video. And that's about it. Usually we are a couple of people sitting here. We have one or two commentators, and then we have one or two taking care of all the technical streams. That's about it. I hope you enjoy our streams.
My name is Niels Foldager, and regarding the Nexø rocket, I have been involved in the engine group that designed the engine. I have dealt with the evaluation of the injector design, and regarding construction, I have dealt mostly with the airframe, where I have made a lot of milling and drilling, making threads, and being on this lathe here.
The Nexø design is the first rocket design of the history of Copenhagen Suborbitals that has been drawn in detail before building commenced. Thomas Madsen did the drawing and detailed mechanical and metal design work using the SolidWorks software. Thomas Madsen was also a part of the team that designed the BPM-5 rocket engine and its one-piece CNC molded injector. After finishing the design work, Thomas Madsen has taken part in the manufacturing, assembling and final adjustment of the Nexø I rocket.
Nexø I kan sagtens stå her.
Jørgen Skødt has welded part of the Nexø I piping system, and furthermore he is part of the visual design team and in charge of production of labels and stickers for Nexø I. Christian Ravn did part of the Nexø I rocket design, especially calculations. He also performed reviews on the other parts of the design. Christian Ravn designed and manufactured the burst disc system that serves as a secondary safety mechanism guarding against tank rupture due to unintended overpressure.
When you look at Nexø I, you see a lot of threads and a lot of screws, but not so much welding. And the purpose of this is that the engine, the rocket, is easier to assemble. Things can be bolted on and taken back off and fitted back on again during the process. And this is also more serviceable should something happen to the rocket that needs to be repaired. We have also had a different design process this time. Everything has been drawn in CAD beforehand, so we have known up front how we would fit all connectors and pipes and wires so that nothing got in each other's way. And as such, this has been a good structured process, and also a process where it was easier to involve many people in a team effort because everything was planned ahead.
The other thing I'm looking very much forward to is seeing this seemingly very small engine propel this very large Nexø rocket high up in the sky. It looks, the engine looks small in the airframe when you're looking at it, but it's still good for more than half a ton of thrust. So it will definitely get off the rail. I'm just waiting to see how high.
The end of the roadmap for Copenhagen Suborbitals will be the Spica rocket. And the Spica rocket is our manned launch vehicle designed to carry a passenger vehicle of approximately 300 kilograms to an altitude of 100 kilometers, slightly above, so as to reach the Kármán line and bring back the passenger alive. It's a substantial rocket from an amateur perspective, and the technologies required to do that are those that we aim to demonstrate with the Nexø rocket series. And this is actually why we do the Nexø rockets as a stepping stone towards realizing Spica. We need to demonstrate the ability to run biprop systems, all the control, the DPR system, the pressurization systems, the avionics involved, the recovery systems, and all those subsystems need to be realized from scratch, because it's not technologies that were previously available in Copenhagen Suborbitals. And the Nexø rocket series will allow us to do that. The Nexø I rocket will be the first step down that path and will allow us to evaluate a biprop rocket system and in particular the startup sequences of the engine at sea, the operations associated with tanking and detanking and working with biprop systems in the rough environment that a sea launch does involve. And it'll allow us to work for the first time also with composite structures and more lightweight designs than we have previously worked with in Copenhagen Suborbitals. So the Nexø series should be considered a vital stepping stone towards the future of Copenhagen Suborbitals, the Spica rocket series.
So we are apparently back, and hopefully you can all hear our audio. Right now we are in the process of almost filling on liquid oxygen to the tanks. What can we expect to see here in this process?
Well, as soon as the LOX tanking is started, the launch will be quite close. The rate with which the LOX will cool down the tank on the rocket is more or less determining how long it will take before we launch the rocket.
Yeah, and unfortunately we just lost the image to Sputnik, and that's not very important here up on just close to launch. Damn, this is a tough day at work. Tough day to be a volunteer speaker on Copenhagen Suborbitals. We are looking here at now at the Sputnik platform. I haven't seen any smoke from the rocket yet.
No, any liquid oxygen fumes, or we should say condensate. No, they it obviously looks like they haven't commenced the tanking yet.
Okay, so we're just right now in the process of preparing. The crew are preparing themselves for LOX loading. That is, we are past point 4.5 in the checklist that is closing the avionics bay, but that was about 10 minutes ago, 15 minutes. So we are probably a bit further on. Some of the arrows in the graphic in the video feed looks like smoke, but I don't think there are any visible signs of LOX tanking yet.
No, not as I can see, not yet.
Okay. Why? As the LOX tanking begin, things move quite a lot faster.
Yes.
Why is that?
The LOX is, as already mentioned, very cold. It's cryogenic, so it's minus 183 degrees.
Yep.
That's the boiling point of the liquid oxygen. And as it enters the tank, which is quite hot compared to the oxygen, it will immediately start to boil off.
Okay, so it has to cool down the tank.
So it has to cool down the tank. And as soon as the tank has cooled down and the LOX isn't boiling anymore, but is just evaporating like hot water would do in a cup of coffee, then it's time to start pressurizing the rocket.
Okay.
But of course, as soon as they have determined that the LOX tank is cooled sufficiently off, they will evacuate the launch platform before commencing with pressurizing the tanks.
Okay.
So we'll. To me, it looks like they have reduced the number of persons on the launch platform already, so they should be quite close to commencing the LOX loading.
And why do they reduce the number of personnel?
It takes some time for to move people from the launch platform to one of the other ships.
Yeah.
So they have to take that into account.
So that's the small red motorboat that you see. That's the one moving people to and from the different ships in the fleet.
Yes.
So between Vostok and Sputnik, and between Yori as well.
Yes, and also Antares.
Oh yeah, Antares as well.
Yeah.
So right now I'm guessing that we're only seeing the picture of us. We are waiting for the stream server to boot up again, and we are sorry for that, because we know that you want to look at rockets and not fancy t-shirts. But at the moment here we are still waiting for the LOX tanking. When the LOX tanking has taken place, things will move faster and faster, and up until launch. So as soon as the LOX tank is completed, then we will see a very fast, rapid moving down the checklist. How do you know how much liquid oxygen is inside? I know that's a big challenge to know that.
Yes, that has given us quite a lot of problems up till now. The way we determine the amount of liquid oxygen in the rocket tank is by weighing the complete rocket on the rail. we have a load cell placed beneath the rocket, and we have a rod connecting the load cell and the rocket, so the rocket is standing on the load cell, so to speak.
So it's being constantly weighed?
We are weighing the rocket constantly, yes.
Okay.
So we are like determining what is the weight of the rocket just before commencing the LOX tanking, and then we see what the increase in weight gives us of that will indicate the amount of LOX on board the
How
rocket.
precise is that weighing off
We have determined that with the present setup, we have determined during our sea tests and harbor tests that we are within plus minus 2 to 3 kilogram.
I need that again because we're talking on the radio.
We are able to determine the weight to within a couple of kilograms.
Oh, that's impressive. How much LOX is loaded?
The LOX loaded is you'll have to check that in the flight plan, but it's around I think it's around 40 kilos of LOX.
Okay, so there's quite a actually a bit of uncertainty of how much LOX is loaded.
No, that's just because I don't know the exact amount.
Okay.
But
Fair enough.
It is in that order of mass.
Yeah. Are you aware that ved du at der er problemer med at vi kun ser os eller i streamen? Okay.
Bad flight.
Sorry for speaking Danish. We will be monitoring.
Peter will just reconfigure something on the video. It's overheating. But we'll continue to step 4.11. We have turned off the video. So we'll continue to 4.11. Over.
Roger, this is pad commencing step 4.11, moving baskets to open position. Over.
Yes, please. We will wait while you do that. Over.
And now hopefully you will see the technical mosaic, or at least what was supposed to be the technical mosaic with a lot of feeds down. We can... what are we seeing here? Can you...
We are... Oh, sorry. We are seeing the bottom basket on the launch rail is moving out to allow the rocket's fins to pass.
Yeah.
When it launches, so the actuator has moved the basket out of the way.
What is the launch rail? That is the red tower.
That's
What's the function of that?
The function of the tower is, of course, to hold the rocket until it launches, and also to guide it on the right path for the first 20 meters.
Okay.
The active guidance of the rocket will not start until after the guidance system have detected that the rocket has gained 20 meters.
We confirm
Okay,
step
so
4.11, complete move gets to open position.
that's exactly the
Both
height of the
baskets
tower.
are in the
It's
open
approximately
position.
the
Over.
height of the tower. It is.
Very much. Over.
It has left the tower before the.
Yordi, flight.
So, rather.
Can you verify that the range is clear of interest? Over.
Range is clear.
Start guiding while on the rail.
Thank you.
Will work against the railing. Yeah. Okay. So that's simply to avoid. So it will be shut up, and then,
Her i order.
the tower, then it will take over.
Yeah, the guidance will start.
I holdet indast 0,6 skilt.
And we have not seen any tanking yet.
Rød, det er indforstået slut.
See any vapors from the tanking?
Johansen flight.
Okay, and we have, as I'm able to hear or being updated, that we have verified now that the range is clear, and also that the stream is somewhat up and running. That's us, and it's
Pad flight.
Yes.
Yes, we even have.
This is Pad over.
Views I can see.
We are carrying out 414. We're contacting ATC Malmö. Over.
Roger, this is Pad standing by, over.
Pad.
This is Pad, over.
While we do that, we will commence on the checklist. We would like to null the load cell in step 5.1, so please stand clear of the rocket, over.
This is Pad, please stand by, over. Flight, this is Pad, I can confirm that there are no hands on the rocket, over.
We will null the load cell. Stand by. Pad flight.
Okay, so we're still waiting here. We are at the point where we're
this is
supposed
Pad,
to
over.
call the ATC Malmö.
You are go for step 5.2, connect logs line to launch flange, over.
Governing the airspace above,
Well, we will commence step 5.2, connect logs line to launch flange, over.
They will have to tell airplanes in the area that they have to avoid
Flight
this
Pad, over.
Area because there's a
Go.
rocket launch going on.
I'd
so
like
we have,
permission
we right now
to make
effectively
sure
keeping
that we
other planes
increase
out of the area, or is
helium
that
supply
only
pressure.
later?
30 bars, bars,
That's my
over.
current guess that yes.
You are go for doing the over.
That will do that after connecting the box fueling line.
We also looked at the flight radar early on, and we can see very early today that there were no planes in the area ESD 13019 that is the shooting area, the special danger area that we are allowed to shoot within.
Yes.
So how is the that's the Pad who is going there?
Yes.
Yeah.
Jakob is the pad leader. He's the one who orchestrates what is happening on the launch platform.
Okay.
Or the pad, also called.
I don't know if we have stream access to Sputnik right now. Yeah, we have it here. Pat, if you look at the top left window, that is Jakob, and he is the one responsible for that everything goes to plan. He is communicating back to Christian Elof. Is that correct?
He's more likely communicating back to Thomas Pedersen, who is has the role of flight.
Okay.
Flight is at mission control on the Vostok vessel.
Yeah.
And they
can we see him in any of the pictures?
No, they are not present right now in the pictures.
Okay.
But also we can see that Rune, who is running the gas station on the launch platform, I think he's connecting the logs line to the rocket right now. So loading logs should be Right, coming right up.
The boat in the background coming in on the picture here, is
Yes.
that Copenhagen Suborbitals boat, or is that another boat?
It looks as if it is. If I'm not mistaken, it's Blue Rip.
Yeah.
Flemming Rasmussen's boat.
Yeah.
Who,
Stefan, flight.
Flemming Rasmussen is part of Copenhagen Suborbitals.
And they are getting ready for the blue boat. That was for recovery.
Both recovery and personnel transfer between the boats.
Okay.
Up until time of launch.
And then something that is I'm curious about.
Stefan, flight.
Just left of the.
Plane to flight. What is your expect?
I don't know what it's for, but there is a bottle mounted to it, stripped to the pole. What is the purpose of that pole?
Yeah, that's a soda bottle. It's there to avoid the wind
resonating
the mast there. So
okay.
It's a very simple and low-tech measure to avoid the mast resonating in the wind.
It's like the computers are pulling the tension card on us. We are losing a signal to Sputnik right as they are about to connect the LOX tanks and start putting locks on the tanks. That's not very fortunate for us, but we will come back with the information as soon as it's there.
Thank you very much. All right, Pat, that means we're ready to load locks. We would like to open the vent valve. Do you concur? Over. This is Pat.
Okay, and now we have confirmed from Mads Wilson aboard Vostok that yeah, I got it. That LOX loading has begun, so that we are after 0.51, that is null loading the load cell, that is to be able to weigh out the amount of LOX that is being put onto the rocket that we talked about before. Then we have also seen that they, before the stream cut off, that the LOX line was put onto the launch flange. What is that? What is a launch flange?
The launch flange is a part of the launch platform that connects the gases and the fuel to the rocket from the launch platform. It's a part that is will be left on the launch platform as a rocket launches, and it's quick couplings simply to connect the lines going up to the piping going up to the tanks with the tanks on the launch platform, from which the various fluids and gases are fed to the rocket.
And now we have another server breakdown because of heat in Vostok, and so that's why you are only seeing us and not the rockets, as I guess you're here to see. that is very unfortunate, but be assured that everything will be recorded as we go along with the checklist. We are past now the point where that is where we are starting to load liquid oxygen, but we are not past point 512. That is that they have to verify that the stream is up and running and that the range is clear. I'm not sure how important they value it when if they should continue on the launch or wait for the stream to come up. So yeah, We'll just hope that...
I'm in the dark there as well.
Sorry?
I'm in the dark there as well, so
Yeah.
Your guess is as good as mine.
Okay, while we wait for news, then we can show a little experiment here. That is the parachute reefing, unreefing system, I guess it
Yes.
is. After the ballute, we have a model here, has been deployed. Some time passes and then it is cut off.
Yes, determined by height and a timer. The ballute is disconnected from the rocket, and then it is only connected to the main parachute,
Yeah.
which will then be evacuated from the rocket by the ballute.
Okay. So, and as the parachute comes out first, it is reefed, as I talked with Jørgen about earlier, and that means that it's tied in so that it's kind of make sure that not too much air goes in and destroys the parachute.
Yes.
But in this thing here, that's the wire cutter for the reefing system.
Yes, that's a timer that as soon as the reefing line, which is run in the bottom circumference of the parachute, is tightened because of
like this.
We just want to show first that this one can move on the line.
Yeah.
And which makes it much easier to install.
Yeah.
But then what we did yesterday evening, we removed the pull plug from this to activate it, and now you can hear it beeping. We'll just I'll just connect this one because the cotter is not put in, but I'll do that right now. Now, and then it probably won't be.
Maybe we could talk about what the purpose of this machine is right now.
Yeah, this is
maybe we should put it closer to the camera as well.
This is a timer which will, from the moment that the parachute is deployed and the reefing line is tightened, it will say from now on there will be a 15-second delay, and then we will cut.
Radio net for the LOX loading process. We will need the clear radio net for the LOX loading process. Out. It's a little more frequent readouts on the LOX loading process, please.
Okay, LOX weight right now is 17.9 kilograms, 1.6 bar pressure against minus 120 degrees.
So this is flight. Can you report a target LOX loaded mass over?
Target mass is 30.7 kilo, over.
This is pad, acknowledge, thank you, over.
We are at 26 kilo. And 1.3
Okay, so I guess we're back on.
Yeah.
Roger that.
Okay, so does that mean that they have completed the LOX loading?
I'm not sure. I heard all of it, so I can't tell you that for sure.
Okay. LOX loading completed?
We are at 36 kilos and 1.5 bar. Are you still flowing, over?
Okay, we are still loading LOX, I guess.
Yes.
Alright, let's
They
keep
are
it here for a minute or two and see how the load cell settles, over.
They said 36 kilos.
36 kilos of liquid oxygen, so
Yes.
we are pretty close now.
They are just taking a bit of time to see it stabilize to get a better readout of the weight of the added logs.
Yeah, and that gives us some time to get the servers up and running, hopefully.
We hope.
Yeah. As it is right now, we have no live feed either, not from the studio to what's happening here. So we are equally in the dark here, unfortunately. So yeah, it's like there are some heating trolls around here, constantly pulling plugs.
Seems like it.
Damn it.
We are currently reading 37 kilo, 1.6 bar, over.
Okay, and we have 37 kilos of liquid oxygen on board the rocket. Nej, jeg tror bare vi skal blive...
Go past.
Pressurization rate might not be that high. Apparently it looks like it's only the pilot valve that's open right now, over.
We're at 1.7 bar.
Sounds very credible. It'll just open up the main valve.
Okay, right now we are of course working hard to make the stream come up again. Could the producer put up the audio level from the VHF radio?
Stand by.
Yeah, Lars Bjergård, we are on it. We will turn up the audio from the VHF. Unfortunately, this is at the moment a radio show of watching a rocket going up. At least you got to see it before it launched.
Yes.
Hopefully we will get the servers up and running before launch.
We hope so.
Are you hearing the VHF audio as it is right now? People in the chat? I see a lot of smileys. Okay, there's no audio from the VHF at the moment. Yeah, we have jump scare VHF. So be prepared to turn down the audio. Okay. There is no VHF at the moment, and we are ahead of
Pad flight.
here.
Pad over.
So I have two things. First, when I said 36.7 kilos, then we actually have to add an additional offset of 5 kilos, because when you hooked on the LOX line, we saw a 5 kilo offset. So the actual target is 41.7, over.
Peter, betyder det, at vi er på vej tilbage med stream?
Pad, sorry, flight, this is Pad for LOX.
Okay, there is
we are
some
a
kind
little
of
bit
development in
worrying
the
about
stream
the current
situation.
loaded
We are hopefully
LOX
getting the
mass.
stream up and running.
We would like to suggest a temporary removal of the LOX loading line, just to make sure that we don't get any additional tension from the super-cooled copper LOX line, over.
Alright, you go for removing it, over.
We'll proceed with removing the LOX line to just make sure we get the measurements right. We'll report when completed, over.
Okay, and while we wait for the stream to come back running, we can take a look at one of the engines that actually blew up, and I don't know if it's due to not cooling it, but here it is. Ah. Could you hold this part?
Oh yes.
What engine are we looking at here?
Well, you should have prepared me better because I'm
Okay.
not sure which one
guess,
it is.
I guess it's blown up. So here
Yes,
it's
very much.
at least a proof that cooling is important here. This
Yes. It might be an engine that had a hard start. One of the very first experiments with
Flight pad over.
dual liquid engine with LOX and alcohol, which happened.
Flight pad over.
Okay, so it's not
Go pad.
there's a lot of
This
fuel
is pad
in
for
the
LOX.
chamber,
We have
and it just
dismounted the LOX
starts
loading
too
line,
fast.
and
I think that,
you can proceed with weight measurements over.
I think that the cause of this.
Right, thank you very much. Toward and get back then by.
Så.
Jeg har byttet om på de to. Er du ikke byttet om på de to?
Jamen det er ikke,
Nej.
det er ikke det der er problemet lige nu.
Hjorte flight. Det er Hjorte skift.
Det er Hjorte, kom ind.
Ja,
Okay.
vi ser to skibe i området. Ser I dem skift?
Okay, apparently we have two ships in the area that are not supposed to be there, and fortunately we have the stream up and running again.
Mm-hmm.
Ja, Niels, vi ser endda en på vej ind i området. Mod syd har vi en WLA 84 på vej ind i området. Mod syd har vi også en Arcona 410, der ligger ind i området. Skift.
Okay, so we have some issues with the people inside
Vi kan bekræfte
inside
den
the shooting
ene, men
area.
ikke den anden. Skift.
And but now
Okay,
you can
hvorfor en
see
til?
actually the apparent smoke coming
vi
from
sætter
the
noget i
rocket, and that is not due to anything being wrong with the rocket. Just
No,
so you know.
that's because of the cold liquid oxygen in the tank.
Yeah, it's actually like putting out a very cold soda in a hot summer day with a lot of moisture in the air. Then you will see the same.
Exactly.
We have had no hands on the rocket. Can you give some weight measurements over?
Yeah, so currently we're at 32.6. Over.
And how much does that differ from when the LOX loading line was attached over?
It dropped about 3 kilos when you disconnected over.
Thank you very much. Do you have any preliminary information on boil-off rate over?
It is tricky to say since we're bouncing up and down a kilo or so. So our impression is that the boil-off rate is very low. Over.
Is the reason for the bouncing of the loading cell, what is that?
Even if the rocket is moving on the rail, it will generate a variation in the load on the cell.
Okay, so it's not because of bubbling of the liquid oxygen.
No, it isn't that. It's simply because the rocket moves on the rail.
Okay.
But they are
I concur.
from the
Reattach
load,
LOX
so
loading line.
it's filtered heavily.
Okay, now they are reattaching LOX loading, so they are continuing loading liquid oxygen to the Nexø I rocket.
Yes.
So now we are continuing on the checklist.
har snedet sig ind i området fra syd. Vil I gå i retning 180, så hurtigt I kan, men udenom Sputnik skift?
Det er korrekt. Vi går 180 skift.
Ja, modtaget slut.
We have a team out to keep the area clear. We have some problems with some ships not being in the area where they are not supposed to be, in the danger zone ESD 13019. If you want to look it up yourself, you can go onto the page that's called openstreetmap.org and search for ESD 13019. Then you will be able to see the area. And right now we are 35 kilometers east of the coast of Bornholm. Maybe we can bring up number 46 while we wait. And in this, we are in this shooting area, or in this danger area, where we can do all our dangerous boys stuff, and we are supported by 5 vessels. We have our launching platform, the Sputnik.
I concur. Let us wait, and
is the Sputnik custom built for this purpose?
This is Pat standing by, over.
Is Sputnik custom built?
Yes, it is. It's built for this sole purpose to launch rocket from the Baltic Sea.
Okay, so we don't have there's not a reason for someone building a catamaran like this just
for pleasure sailing. It's totally not suited.
Okay.
It can sail around 5 knots.
Okay.
So it's a very slow vessel.
Yeah, let's get back to the live stream where we have currently the rocket being loaded again, topping up with the LOX. They were at 36 kilos or 37 kilos, I think I remember.
Yeah, at some point, yes.
Yeah. And now they have just received a message from them that the LOX is continuing. LOX loading is continuing.
Yes.
If we can just bring out the picture 57, then we can see the LOX tank. And the LOX tank is here is able to how much liquid oxygen was it that was space for here?
The tank is 60 liters all in all,
yeah.
And then we fill it to around 2/3 full of liquid oxygen, so we have 1/3 of the volume for.
Okay. Someone is yelling very loudly in the VHF radio. Wow,
Yes.
it must
Hard
be
to
windy.
concentrate.
And it's there's also time here. If we could bring half stream, half this picture, if it's possible. When we load in the 60 kilos of no, was it 60 liters?
It's 60 liters
Sorry,
all, but we load around 40 kilos.
Yeah. 40 kilos, and it is mixed with the ethanol as it is being pushed down, and you said it was filled up to 2/3 with liquid oxygen. Is that the same with the ethanol tank?
That's the same with more or less the same, yes.
Is
There's
it the
there's
same?
a small difference, but not very much.
Okay, is it the same ratios
we're having a bit of range safety issues. We have a boat in the area. We need to clear it out. Over.
And we sadly we cannot launch Nexø I right now. Not Sputnik. We cannot launch Sputnik. That's fortunate. Unfortunate. That would look cool, but yeah, we have some range issues, and that means that there are people in within the launch range that shouldn't be there for safety issues. Okay, but yeah, is it the same amount of
in the order of
It's
4
very
kilos?
close.
I suggest that we fill them
there's
on
a
now
small
while we're
difference,
waiting, and then we'll see how the situation progresses with
between
the
the
shooting
amount
vessel.
of loss
Over.
and the amount of fuel, but it's not very much.
Okay.
I don't know the exact numbers.
We should just also
Okay.
increasing the current LOX mass. Please again. again state current LOX loaded mass and target loaded mass, over.
So now we are in a camera that's a bit affected by the waves, but we are looking here.
Alright,
I'm
so
almost getting
the,
seasick looking at this.
Indicator is
Please,
36
cameraman.
kilos. So I just
steady
need
up.
to remind
That's
myself, do you
hopeless.
have the LOX line connected right now? Over?
This is Pat for LOX. LOX confirms the LOX loading line is in place and mounted, over.
Okay, and we are
Alright.
loading locks,
So we're at
continuing to do that.
35 kilos, we need to increase to 41. So we need in the order of 6 kilos. Over.
We are very close to being able to evacuate the platform.
At least we are very close to having loaded the amount of locks that we want to load.
Yeah, but
LOX
afterwards
tank
we need to
pressure
verify
is,
stream is
currently
up and
at
running. That's 0.512 in
bars.
the checklist. I'm sorry that I spoke over that. We are currently still loading liquid oxygen, and that is happening while we are clearing the area.
Do you think the vent valve, main valve is open, or is it only the pilot? Over.
This is Pat. I only see the pilot valve open, over.
Because we're getting at 5 bars now. Do you reckon that we should try and close it and open to see if the main valve opens? Over.
We generally concur. We will just stop the LOX loading in between, so please stand by, over.
Okay, and what valve are they checking here?
They're checking the valve at the top of the tank that is used to ventilate the tank.
You need your in here. Sorry.
They use that valve to make sure that the pressure won't build up while they load the LOX into the tank.
Okay.
If they load too fast and the ambient is very warm compared to the LOX, they might run into a problem with the valve not being able to vent the air, the evaporating LOX quickly enough, and then the pressure inside the tank will rise. But then they'll have to stop tanking and wait for the pressure to fall again.
Okay.
Go, Pat.
And that there's Pat. That is Jakob, right?
Yes, that's correct.
He is.
The LOX loading process is currently stopped. We suggest that you commence with closing the LOX vent valve for a certain time and then reopening it. Over.
Okay.
I
So
suggest
now
that you
they're
close for 3 seconds and open basically immediately. Over.
This is Pat.
Jakob, he told him that they could close the valve after they have stopped loading on the liquid oxygen. That is.
De to mål på vej ned mod. De skal simpelthen bare vende næsen mod syd og væk så hurtigt som muligt. Skift.
Okay, that was Danish, and that was Jorder. That was very strict. He was very strictly and promptly saying that those vessels that was inside the area are supposed to move out immediately.
To turn around.
Turn around in the opposite direction. Please go back from where you came. Okay, but they shut the valve and then they look at the pressure buildup in the
we will
liquid
close it
oxygen
again
tank.
and try reopening. Over.
And they try it again now.
They will try to cycle it open and closed and open.
Yeah.
To see if it will vent the tank.
Yeah. Ah, so it's a safety procedure. This.
Yes. It's
Rødgrib her i Order. Det nordligste af de to fartøjer kommer til skal gå 4 sømil mod syd. Det sydligste skal gå 3 sømil mod syd. Skift.
Okay, and that was again Jorder. That's home
About
defense vessel. Being very strict with orders of where the two unknown vessels are supposed to, the unknown boats are supposed to go to.
Yes.
And now we are hearing a pressure build-up in the oxygen tank. We are at 6 bar. And
yeah, they are making sure that the vent valve will open again.
Yeah.
Pat,
They are very. That was the seasick picture again.
We're at 6 bar right now.
Sorry,
Can
people
you,
out there.
even, put more
Oh,
logs
he's
on it with
steadying,
that back pressure over?
steadying the cam. That's awesome.
This is bad for logs. We can certainly add more logs, but yes, we only see pilot valve operation over.
And now we also have a reminder from our audience for our audience, and that is that you can switch up the quality of the stream. You're not watching it in full quality. Our producer asked you to switch it up to HD. That is not full HD, 720p. You can do that by pushing the gear button just under as part of the right button part of the screen.
This is bad over.
So please, for your own sake, change it to higher quality if you're able to get the stream.
Yes, we are opening and resuming logs loading process now. Please keep readings going over.
Okay, and people are. It's about half of our audience that are currently on the low quality stream. So you are able to. Most of you will be able to push it up to 720p if your connection is stable enough.
Flight, this is Pat. We are resuming logs loading process now. Over.
Okay,
Thank
and
you.
we have a
6.5
very
bar.
important message here. That is that we are 10 to 15 minutes from launch. That is very good news. We are looking forward to it, to be able to see the
7 bar.
rocket hopefully leaving the rail as planned. The flag, is that going to be removed before launching?
No, I don't think so. I think they will leave it there.
29 kilos.
And there's no
8 bar.
concerns about burning Danish flags on this vessel?
No, the flame shouldn't reach that far out.
Okay, it shouldn't reach that far out. That's very reassuring. Oh my god. Yeah.
Oh, I can see there's a plastic box holding some cameras right next to the flag, so if the flag is harmed, so are the cameras there.
Okay.
Those are two high-speed cameras looking directly into the sky, trying to catch the view of the rocket.
It actually looked like the pad leader was holding the flag for a minute
Yeah,
there.
you're at 8.4
okay,
bar.
but we are almost at the point where logs loading is stopped, and when logs loading is stopped, then we have to pressurize the tanks.
Yes, first after logs loading is completed.
Yeah. Okay. All ribs. We need you on station to pack screw away.
We will have to. The photo crew will
Det
start
er
on the
rib, blå
high-speed
rib, vi
cameras,
skal op og lægge til nu. Skift.
and then the platform will be evacuated before pressurization starts.
Jakob, vi har vores lastcelle, den er off, fordi vi har højt tryk i tanken, så I skal stoppe logsloading nu. Skift.
Pad for logs. Logs loading is stopped. Over.
I er på 8,6
Okay,
bar.
and Peter, could you put the stream as a full screen with the timeline under? So there's no reason for looking at us. Maybe there is, because now we lost stream. God damn it. Ah, gee.
Jesus.
Okay, no cursing. Looks like we are on a reboot again. That is not the situation that we were looking for.
Absolutely not.
Okay, Jakob, vi skal hurtigt videre. I skal lukke logs linjen, og så skal jeg gøre klar til at forlade skibet. Skift.
Okay, they're. Okay,
Yeah, I think
are we able to get anything, any pictures? Okay, we are getting the information from the producer Peter Mask, who is on it right now. He's trying to reboot it. We have lost one of the servers permanently, I'm sorry, but yeah, we are working on getting the other one up and running. Damn.
Yes, it's unfortunate that this is a point where they can't wait for us.
Yeah, we are past the point where they can stop and hold.
They simply have to carry on their schedule from now on.
Yeah. If you guys know of any other streams that are sending this, please put it in the chat.
Yeah, Jakob, we stand by.
Could you bring up the checklist?
Yeah.
We was asked where we are.
Yeah, but what's the area of the coupling we're transferring logs through? Over.
We are at point 5.15 or 5.16.
Okay.
What is the area of the
very close to launch right now?
Very close to launch, yes.
This is Pat. It's a 12 millimeter diameter copper tube, so
oh, this is too exciting. I can't bear it. Jesus.
At least we'll hear the cheering or the or the booing.
Not booing, I hope. Oh, maybe we should start drinking instead. This is kind of. Oh, Jesus. Yeah.
Ja, vi skal mere logs på. Over.
And hopefully some good news from the servers.
Oh yes.
Please. Cross your fingers out there, please, all of you.
Flight, pad over.
Go.
Logs pressure, please.
8 bar.
Over.
Okay, so they are pressurizing the tanks right now.
Thank you.
I heard the message that they need a bit more logs put on the rocket.
So maybe we are fortunate enough that we are able to...
Maybe they have a small delay that we can use for getting servers up.
Yeah, I would like you to try and load a bit of logs on, over.
Okay, maybe we are lucky. Yeah, we are getting up and running again. That is...
live pictures.
Can't stand this.
Roger.
Okay. Okay, I hope you guys are seeing the stream right now, up and running again, and please keep your fingers crossed. Yeah.
Flight pad over.
Yeah, go.
Estimated additional logs loading mass over.
10 kilo.
Repeat over.
10 kilo.
10 kilos, noted. Flight pad over.
Yeah, go.
Commencing slow logs loading, over.
Go. Order her mission control.
Her i order, skib.
Det er i order. Den båd, der hedder Mentor, der ligger ind på vej mod Nexø, har I haft kontakt med dem?
Ja, det har vi, og de har været uden for området et stykke tid, skib.
Okay, det er modtaget på vores det ser det ud som om, at de er inden for området, skift.
Yeah, they are loading more logs at the moment, but unfortunately we have a server
Ja, i
problem
ordre,
again.
det passer ikke med vores
So
radarskilt. Jamen det er modtaget, hvis jeres radar siger det, så stoler vi på det. Det er fantastisk, tak.
yeah.
Yeah, Pat, we're at 8.5 bars. Are you transferring logs over?
No, we just shut it down because of the chatter, so we would like to be advised over.
8.5 bar, you are go. 10 kilos, please. Over.
Logs loading.
Okay, they are still fueling logs on the tank.
Yes.
So maybe, just maybe, we're in luck that we'll be able to open up the stream for the launch.
Let's hope so.
Oish, this is terrible.
Well, at least it gets suspense.
Oh yeah,
For
too
all your
much
money.
suspense. Yeah, I really don't need suspense at the moment.
Come on.
God damn it.
8.6 bar.
Okay.
8.7.
When I'm looking up to this side here, the left of your screen, to my right, I'm checking if
8.9.
the servers are up and running again, and so that's why I'm a bit distracted this way, because we don't see
9 bar.
anything in the screen in front of us, as well as you don't. We only see ourselves, and that's a bit annoying.
Oh, to say the least.
Yeah.
But it looks as...
Don't you know a good joke? Something that could relieve the tension.
9.3 bar.
I'd rather not.
Yeah.
Well, at least it looks like, or it sounds like we have turned around the
9.4
boats that
bar.
was violating the area, keep out area, and they are outside the range.
Yeah.
Go back.
And, please out there, if you have some family's fingers to cross, please cross them. I have no more fingers to cross than I have at the moment, and also my legs. It's not because I need to go to the bathroom, it's just the way it is.
Yes, do you have any suggestions? Over.
We have a special space.
This is Pat for logs. We're currently
Okay, I'm told that if I need to go to the bathroom during the stream, they have a special astronaut
Roger.
bag that I can use. And I hope not that will be the case. Oh god.
Flight, can you please report on the logs pressure? Is it
Yeah.
steady or dropping? Over.
Ah,
9.3
you are
and
being,
it is pretty steady. Over.
people are saying that you are extremely calm.
I have to be. I have to be.
I can't understand
All
why.
stations, this is Fido.
Are you
Please
able
notice
to?
that the launch window closes in 18 minutes. That is
Okay, there are
18
pretty many
minutes.
bad jokes about space. And yeah, maybe, just maybe, there's a slight chance that the stream is up and running. I can see that
Some of it is.
yeah, maybe some will come to you in a second. No, there's not
Flight,
plenty
this
of
is
time
Fido.
to go to the bathroom. I
Yeah,
can say
go.
say you that.
I
Yeah.
can confirm that the area is clear. The area is clear.
Roger.
Stream.
Flight Pat over.
Go.
The thing is that we actually people are actually able to see some of the stream right now in the in the poster and behind us.
Oh, yeah.
Roger,
Maybe we
go.
can put it in here. No, you're not able to see anything here. Damn it. I hope it would work as a mirror. Are we having the stream to our audience, our viewers?
9.6 bar.
Like a view from Vostok.
This is Pat. We seem to have some logs flow. Please report the masses over.
Den kører ikke til dem, vel? Streamen. Lige nu er det bare os, der er på.
9.7 bar. We don't see any increase in okay, that was an increase in mass. 3 kilos increase. You are heading for 10 bars now.
Okay, so we had a slight mistake of numbers here
Flight Pat over.
with the stream.
Yeah, go Pat.
I've just confirmed with photo that they have space and power
And we
for at
can
least 18
assure
minutes.
the
Suggest,
viewer who was concerned that we are
activating
going to
all
nuke them,
cameras
that
now,
that's not
over.
the purpose of
Yes,
this
please,
rocket.
all
It's only a
cameras go now.
technology test.
It is.
And we hope that we will be able to show you everything that's, yeah. Oh, nice network box.
Mm.
What, yeah. Here,
Du har 9,6 bar,
that's better.
og så har du cirka 30 kilo.
Let's look at the rocket. Okay, we're at about 30 kilos of liquid oxygen now. Weren't we at 36 kilos before?
Yes, but it may either it has boiled off, or although they have problems with the load cell readout.
Yeah, and now the servers are up
All
and running.
stations, this is
Please,
Fido. The area closes in
all good
14
karma
minutes.
towards
The area closes
our
in
media
14
servers.
minutes.
How long time do we estimate before launch? I mean, they have to evacuate. That's going to take at least 20 minutes.
Yeah.
Yes.
Flight, we need logs masters, over.
Ja, Jacob, problemet er, at det er svært at sige. Altså, vi har et estimat på 30 kilo. Det kan være 35. Det er svært at sige. Pas. Skifter.
Er den stigende?
Svagt stigende. Okay, Jacob, nu er du hoppet den lige 4 kilo. Lad os holde den her og luk for loks og luk proppen røret i enden. Skift.
Repeat the last part, over.
Ja, du skal lukke loks transfer, og så skal du sætte lukke røret ned i enden med proppen, ikke? Skift.
Roger, dismounting logs loading line and capping off loading port, over.
Og ja, det skal gå lidt hurtigt. Både det og foto. Vi skal meget, meget snart afsted.
Det er modtaget, de arbejder så hurtigt de kan.
Okay, in Danish they're saying that they are about to be evacuated from the Sputnik platform.
Ja, det er en rigtig god idé.
Service, stay up, stay up.
Oh yes.
Okay, if the servers break down again, I think we'll just open the booze.
Ah,
yeah.
Not for me, please.
And cry ourselves to sleep.
Hvordan går det med at tænde kameraskift? Launch window extended until 1700.
It looks like they just removed the locks hose.
Yes, and they also got an extension of the launch windows. The launch window, which means that the hurry factor is considerably lowered now.
Yeah.
So you have 9.5 bars, and the other thing I said was that the launch window has been extended by half an hour. Over.
But only the rocket.
What did they say there?
Logs loading line disconnected. Logs loading port is capped off. You can do measurements, over.
I can do what, say?
No. Okay, no answer to that. I think he said measurements. Maybe was
we're
weighing the
not going to
rockets
monitor
right
boil off rate. We need to get people in boats and pack them away. Are you ready on the launch platform to be packed away? Over.
We're ready to pack away.
Okay, so you see Jakob is the guy just next to the rocket in the back.
Away, and Sputnik crew goes away, booster crew goes away, you remain
Is
as
that Carsten?
the last guy on the full block. Over.
Oh.
Responsible for gas.
Okay, yeah.
Over.
That's his purpose.
Is Soto ready?
He's minding all the gas loading on the rocket.
Okay. So he's the last guy to leave, or
no,
is that?
the last guy to leave is Pat.
Okay.
Jakob is Pat, and he's the last one to leave, and he will. The launch platform, the last thing he
Jo,
will
det
do
kan I
is
bekræfte, at Akona
insert
er
a-
uden for området. Skift.
Nej, det kan vi
insert a
ikke.
plug
Vi kan
to,
bekræfte, at det stadigvæk er inden for området. Skift.
Det er modtaget. Hvor mange mil er det inden for området?
the pirate to operate. And then, after he has evacuated, he will, via a very, very long rope, he will remove a pull plug that will finally enable the pirate to
Have you verified 517? Verified launch pad is clear of obstacles.
Okay, this is
Can I just
horrible.
looked up against the rocket and patted it over?
Server's broken down so many times.
Don't mention the evil.
Is photo ready
No,
with camera?
I don't think the servers care.
No, probably not.
Her er i ordre. Akona er 2,4 sømil inde i farområdet. Skift.
Det er modtaget. Kan I se, hvor hurtigt hun går? Skift.
Okay, so some new guys are in the area again. The order, the home defense boat is telling that someone is 2 sea miles into the
Jo,
the
vi
area.
ser Akona ude på dens AIS-transponder. Over.
Get out of this area right now. This is
Vi har et sejlskib, som ligger ude på 8 sømils afstand. Og vi har slæbebåden, der ligger på 8,7 sømil. Og så har vi et sejlskib, der ligger syd for Sputnik. Og det ligger 2,4 sømil inde i farområdet. Skift.
Okay, Roger. Kan I få den væk? Skift.
Ja, den er på vej sydover med en fart på 3 knop. Skift.
Og hvor lang tid tager det, den så kommer ud af området? Skift.
Ja, det tager det mest af en time. Skift. Her i Orte, vi vil gerne sende vores rib igen, hvis det er, at det kan hjælpe. Men de er ikke særlig lydhøre, de dernede. Skift.
yeah. And people are apparently have doubts of what you were talking about when you said pyros. They think you said pirates.
Pirates, pyro.
Everyone is a bit confused.
It's not Jack Sparrow.
Let's clarify, it's not pirates. We're not fusing this rocket with pirates, but with a pyro is being...
Nej, det gør lige det modsatte, så nu må du hellere holde lidt øje med, at de kommer ud. Skift.
Ja, det er modtaget. Vi sætter kursen.
Modtaget slut.
Ja, kom det, sag. Så må de være 5 sømil væk, jo.
Yeah, people are asking for the name of the ship that's entered the area, and unfortunately we don't know.
We don't have that name.
I would call them immediately and
Nej,
tell them a few truth about where to be and not to be during a launch.
Well, they don't seem to be in a hurry to leave the area.
Elof, right.
People are declaring war on Sweden because they think it's a Swedish boat. I'm not sure it's Swedish, but yeah, it could be any country actually. So,
yes.
But then again, it could be a Swede. Let's just declare that war.
At least it's as far as we can understand, it's not Polish fisher boats this time.
The Swedes are not trying to steal the rocket.
Med den højde, vi regner med, har vi en maksimal downrange på 5 mil. Skift.
Okay. They are talking about what the maximum downrange for the Nexø rocket is. That is how far it can travel, and that is a maximum of of 5 nautical miles, and thank you for the correction before. It's not sea miles, it's because it's called sømil in Danish. But 5 nautical miles.
Den vil jo formodentlig komme ned i vindretningen, skift.
Okay, and they are talking about which direction the rocket will go to, and that he's obviously saying that it will go downwind. So
yes, as it should.
As it should. Otherwise, we have another invention that's also very interesting.
Mads Stenfald siger vindretning 230.
Okay, so we have a wind direction of 230 degrees. Okay, so apparently the wind is coming from the direction of the boat and...
Faldskærmen vil flyve i retning 230.
Oh. So apparently of all angles, the rocket will travel towards the boat that is inside this safety zone. That is simply unbearable.
Det betyder så, at raketten i værste fald vil drive en lille smule vest fra der, hvor skibet befinder sig.
Yeah, people are asking if we can see a map of the closed area, but I don't know if...
området ligger i kurs 180 for øjeblikket, men de har en kurs vestover lige for øjeblikket. Skip.
Okay, and you can go to the web page called Marine Traffics, where you can see the ships that are inside the area.
3 sømil mod syd. Skip.
And you're more than welcome to put in a link in the chat here. It makes no sense that I'm putting in the link. So apparently you can't put in a link in the chat, so that's well, that's a blunder. Okay, and thank you for the link, Thomas Beer.
Og remove short, og så smut skift.
Taget indsætter, remove before flight.
Okay, and yeah.
Indsætter.
Remove insert before flight inserted.
Okay, all ribs to launch position.
So now it's just before evacuating.
What did you say?
No, it's just evacuating time. Pat will be leaving the platform right now.
What about the boat inside the safety range? I was a bit off grid.
I don't know about the status of that one, but at least the platform is evacuated, and that means that evacuation won't.
Har I haft radiokontakt med den båd dernede sydover, skift?
Nej, vi kender ikke dens callsign, skift.
And
Det er modtaget.
while
Kan du
we
give mig en
wait for...
afstand fra jeres radar lige nu, skift? Det er modtaget, tak.
Syd for Sputnik, skift.
Okay. Okay, people are suggesting some politically not very sound measurements for getting rid of the ship. I'm not sure that bombing Sweden or other countries will help us get this launched in time. While we wait for more updates, all the work that is done by Copenhagen Suborbitals is done by volunteers, and we encourage you to go to the Copenhagen Suborbitals homepage. You can find it in the video description, where you can go and donate for to the next Nexø II rocket that will be even more advanced. Will contain the dynamic pressure regulation system and others, but before we can launch that, we need a bit of fundraiser.
And a bit of time.
And a bit of time, of course.
Hjortø, her er Fido, kom.
Ja, Hjortø, skæft.
Hjortø, flight siger til mig, at vi agter at skyde, selvom sejlbåden befinder sig dernede, med mindre at I modsætter jeres skift.
Her er Hjortø, jeg skulle sige fra skipper, at I er velkommen til at fyre skift.
Det er modtaget, tak. Jeg overgiver mikrofonen til flight.
Okay, we're just allowed in Danish by the home defense to fire anyway, so now exciting times are up. Oh, yeah, please move the camera towards... Oh,
well,
are there any cameramen on that one?
Sorry?
Yeah, I'm just worried there was no cameraman on board. Why is it stopping right now? No. Oh.
Ja, Hjortø, skæft.
Oh, yeah, we are there. Still.
This is a view from Vostok.
Yeah.
Nej, du skal ikke vende om, du skal få ham til at komme ud af området, for jeg aner ikke, om skuddet går til tiden. Skift.
Okay. Now we're on board Vostok. In the picture here we see Mads Wilson. Mads Wilson is what is he responsible for when as soon as the launch?
Are you on station?
Sure.
Plane is on station. Antares, are you on station? Antares on station.
There's a call.
Alright, that means pressurization is imminent. Ready for a go, no go call. Pat, are you go?
We have go, no go call.
Yeah, and that
are you go?
We're down in the go no go check. That's 0.62, right?
Photo go.
Yes.
Data is go. Alright, that means we're about to pressurize. We'll pressurize the fuel tank now.
Okay, now the pressurization of the fuel tanks is starting. Can we see the rocket?
Go bad. Be attend.
Okay, we see a lot of sea and yeah.
Facing fuel tank,
Yeah.
3 bar, 5 bar, 6 bar.
Okay, and from now on we can't stop this process, or at least from the when the pressurization is finished, an auto sequence will start.
We can abort.
Yeah,
that
yeah,
will
of course.
Mean, probably that if it is
Fuel line
aborted,
pressure 16
after
bar.
auto sequence start, it might mean no
18
loss
bar.
today. But let's not talk about that.
Yeah, let's not talk about
20
that.
bar.
Right. What is the pressure that we aim for? It's pretty high that we are rising right now.
It's
And
around
it's
20
reached
bar,
the top
a
and it's
bit above.
just keeping it updated.
Okay, and now they are checking if it contains the pressure.
Yeah, probably.
And then they have to. Was that the fuel that they?
They
Yeah,
start
fuel
with the
pressure is
fuel
stabilizing at
pressurization.
21.5.
Right, then you
They
go
have a
to
stable pressure
pressurize
now.
LOX tank at the designated pressure, over. And please keep a readout on the LOX pressure, over.
Yeah, pressurizing LOX side, it's at 13 bar, 14 bar, 15 bar, 17, 19,
Okay.
21,
Okay, and if you see a black picture now, then it will be a picture from within the
Alright,
rocket.
thank you. Am I go
That's
for
just a test.
switching MC box
It's a
to
camera
MC control, over?
that we are able to see
Yes, you are.
from within the rocket when the parachute has
Alright,
launched.
control it as, is that MC box? I will on the igniter. Green light on the arm.
Okay. Okay, cross your fingers out there.
Alright, auto sequence start. Scott, are you ready for auto sequence start over?
I'm ready to count.
Alright, you'll give the countdown and I'll initiate it. Auto sequence start in
Okay,
3,
30
2,
seconds
1,
countdown.
go.
And launch in
Go.
30.
Countdown started, 26 seconds remaining. T minus 20. T minus 15.
Okay, it looks like
T
this is
minus
happening.
10 seconds.
Oh yes.
T minus 5 seconds.
Yeah.
Ignition.
The pyre has ignited.
Oh,
We have liftoff.
it's lifting off. Oh, that's not very fast. Is it? Oh, why? Come on, camera. Oh, stay on target.
Look how
That's
nice it's
so
going.
nice. That's so beautiful. It's regulating. It's wow. That is so beautiful. What a wonderful sight. That is Nexø I functioning perfectly. What a treat. What a treat. Oi, that is so nice to see. Wait, what's happening now?
No idea.
Oh no, oh no, oh no. Oh no, something went terribly wrong.
Altitude on the rocket.
Oh no. Oh god damn it. It's moving down pretty fast.
Very fast.
Oi.
And we have splashdown.
We'll never get that one back.
That was not as it was supposed to go.
No, it
Yeah.
wasn't.
Yeah, we were supposed to see. Oh, it's up. It's still up.
Resurfaced?
Please recover it fast. Okay, the blue boat that is rushing towards the rocket now is trying to recover it before it starts to sink. So they are in a hurry. Wow, they were not out of harm's way there. Please hurry, hurry, hurry.
But at least see how close to launch out that it is.
Yeah. Okay.
Stand by, blow we have a substantial log spoil off. As it is, we have a diver in the water is securing the vehicle.
Okay, we're now.
Oh, this is dramatic.
Sorry?
Stand by, Fleming, hvis I
Still a lot of
log
logs
så
in
skal I
the
stand
tank.
clear.
Okay, they're being told that to stand clear because there's still a lot of fuel inside
Jeg har
it.
helt tydeligt en logs main valve åben, så jeg ser ikke noget safety issue overhovedet. Vi har bare en slowly log spoil off. Okay, så sæt en jordbær i den og hold afstand. Affirmative.
Okay. So no, the engine is not still going. We are seeing
Engine is out.
it's safely venting out the remaining oxygen right now.
That's the word from Blue Rib that the LOX valve is open and the LOX is venting in a controlled manner.
Okay, and do we have a diver out there?
We have a diver in the water to secure the rocket.
Yeah, the producer here is suggesting that we just fill it up and try again, but I'm not sure that that's how things work. But okay, we got a launch today. That was that's a thing, and we got it on camera. That's not bad.
We also got a recovery.
Fleming, Per han skal hægte jordbær i, approach bagfra, hægte jordbær i, og så skal I have lidt afstand. Roger? Roger.
Okay, I think the rocket is secured by a line now. There's somewhere they can tauten it to the rocket, but I'm not sure. He was.
The lock for that is at the motor end.
Okay.
Engine end. So.
And who's the guy in the water right now?
That's probably Per Siebenizer.
Okay, and he just couldn't wait to get into the water.
He's unstoppable.
Yeah. Okay, so
at least it floats.
It floats as long as. But what is that boiling off there? Is that the oxygen?
That's
liquid
oxygen boiling off.
Okay, so no danger there.
And also, it looks like.
Is that what?
The nose cone has been torn off.
Yeah.
That's probably happened at impact.
Except Lux is back on Sputnik. No apparent damage to the vessel. No fires, no nothing. Everything is good here, over.
Okay.
Yeah, close down the close down cameras and prepare to return for next week.
Noted. We're closing down cameras. Over.
Okay, it's a success because no one was harmed and we got the rocket up, but we should have had it up until a height where you couldn't see it anymore, and that was of course not...
no, that didn't happen.
No, that was not the point of this. Okay, he's right now tying the rockets so that it doesn't sink.
I think that it looks as if the avionics part has been cut off the rocket. So it's not only the parachute section, but the whole front section of the rocket.
Yeah, it's gone.
There's a lot of styrofoam
that's styrofoam?
Yeah, in the water.
Okay. Okay, but that could be on splashdown that it happened, right?
Probably, yes.
Yeah.
Morten, se hvor jeg peger.
We had all open spaces filled up with styrofoam to increase buoyancy.
Den er cirka 3 meter fra blå rib styr på side. Jeg ved ikke, hvad det er.
Okay. And the thing you can hear, that's Hjorte, the National Defense, saying that we have some fragments in the water.
I don't think. I think it's either Vostok or Antares.
Okay. Okay, people outside on Vostok are very happy because they got a nice view of all this. And it's not very often that you see a rocket for that long in the air.
Oh, yes.
Of course it crashed, but it didn't burn.
It didn't burn, no.
Yeah. The recovering process is commencing.
Mere til styrbord, jeg skal nok se til, når jeg skal lige ud. 3 meter.
Hvad det hedder, portrætterne?
I 2 meter fra. Din styrbordborg. Se ned i vandet.
At least we have pictures.
Ja, det er portrætter. Det er bare stumper.
The server didn't break down. How did that happen?
It's the camera on Vostok. So now the servers are working.
Hey, yay! That votes well for the launch of Nexø II, which will
well,
hope
maybe not. I wouldn't conclude on that.
Yeah, it's been a rough day on my nerves at least. Okay, and now we have Meiling fiddling around with the camera menu. Please, Meiling, just don't do that. Okay, it looks like the rocket is secured to the boat.
To Blue Rib, yes.
Yeah.
This is what we see is the antenna tower.
Yeah, that was the one that
usually points at the rocket to receive the telemetry.
Okay, why does he keep pointing right now?
It may still be transmitting telemetry, but I have no idea right now.
Okay.
I'm not in the loop.
Okay. And that is there's Mads Wilson.
Mads Wilson probably giving interview for Discovery Channel.
Yeah, and Antares there with the. Yeah, I guess.
That's Carsten Olsen's ship that is supporting the mission. And it looks like they'll
please
take
don't
the rocket to Vostok's aft. and take her aboard Vostok.
Yeah, we forgot to calculate in gravity.
Oh no.
Hjortø, Sputnik pad, skift.
Plane to flight, we are leaving the space.
Roger that flight. Did you get any good pictures over?
Yeah, some of them, we need to check them out, but it should be okay.
Fantastic, Stefan. Can you tell me, did you see the nose cone come off the rocket over?
Actually, the background was that white, so we couldn't even see the rocket taking off, because the background was just white as the rocket was.
Okay, that's affirmative. Have a safe flight at home. See you later. Bye-bye.
Ja, her er Blå Rip. Vi kan bekræfte, at næsekejlen sad på, da raketten ramte vandet. Vi har stumperne af den ombord.
Det er modtaget.
Nu flummer her loks. Kan du holde stumperne op, så jeg lige kan prøve at se mig?
Okay, and we will hopefully be able to update you with more details about what has happened, but probably not today. As soon as it's recovered, we would have liked to have had an interview on board Vostok, but unfortunately we just can't reach the people on Vostok as it is right now. And also, if there is anyone amongst the audience that wants to volunteer to be the man on the rocket, no, of course that's a joke. We have volunteers within the Copenhagen Suborbitals right now. So we have 2 volunteers, but maybe they will pull the plug after this episode. Well, I don't think so. We are a bit far from Spica as it is right now. Spica, that being the big rocket that will hopefully lift a person up to 100 kilometers, where the Kármán line is defining the edge to space. Right now, we just want to thank you for staying with us this long. It has been a nerve-wracking round of occurrences, and we also want to thank all the volunteers on Copenhagen Suborbitals and all you guys supporting us. It is imperative that the support is kept up. So we hope that you're not discouraged by this almost success. We are pulling the plug on this stream now. Thank you very much for sticking around, and please consider going to the webpage and donate. Thank you.
at tage Meinke ind så, fordi han vil også meget gerne hurtigt hjem, hvis du går på vej hjem til roligt.
Blå IFA, det gør vi. Er Meinke på Sputnik?
Meinke er på Sputnik, det er korrekt.
Jamen, så bytter vi ham ud med Meiling, fordi ham gider det heller kanal.
Nej, det kan jeg sgu godt forstå.
Okay, sorry, we're back again. We couldn't leave you just like this. We agree that it was somewhat of a success. And now we have champagne all over the place.
Oh, yes.
Okay, here, Peter, don't look so mad. Here, have some champagne instead. Yeah, it's here. Okay, and thank you to all of you who are still watching us. It's been a somewhat pleasure to make a stream for you. This is for the hardcore fans sticking around for only the return of Sputnik to Nexø Harbor, which will take about 4 hours. So we have some time to kill here. So cheers. Yeah, a lot of hard work, almost a result.
Tak, modtaget slut.
Cheers.
Jorte, Vostok. Ja, Vostok, jeg har sikret dækslasten, og vi forlægger mod Nexø best speed. Ja, det er vel. Sig igen.
DSC RIB. Flight DSC RIB. Ja, flight her. Flight, vi tager Mads med og får ham i land, så han kan komme hjem af skift. Ja, det er meget vel. Tak for indførelsen. Skift. Vi ses i havnen. DSC ud. Carsten til blå rib. Blå rib, Carsten til blå rib.
Orientering for dem, der lytter på, så er Martin her på Hjortø og tager med til Rønne og kører med mig tilbage.
Vostok her i Hjortø, skift.
Hjortø her Vostok.
Her i Hjortø. Vi siger tak for dagen. Det var et flot skud. Og vi går tilbage på kanal 16 og fortsætter mod Rønne. Skift.
Hjortø, det er ikke jer, der skal sige tak. Det er os, der skal sige tak for fortræffelig hjælp og god stil. Godt humør. Vi er rigtig glade for at have jer med på holdet. Tusind tak for en god indsats.
Ja, og tak i lige måde. Meget flot alt sammen. Og vi skal nok hjem og øve lidt med faldskærmen. Men det kommer. Hej med jer.
Det er godt. Tilbage til kanal 16. Tak for i dag.
Vostok her, Sputnik, kunne I lave en præsentation af raketten, mens I sejler forbi? Skifter. Vostok, der er folk på Sputnik, der gerne vil se raketten tæt på. Har I mulighed for at vise den frem med den måde, I sejler forbi på?
Sputnik, Vostok.
Vostok her, Sputnik, skifter.
Nu har jeg hul igennem til dig. Gentage, hvad du sagde før.
Der er folk på Sputnik, der gerne vil se raketten tæt på. Kunne I sejle forbi, så vi kan se den? Skifter.
Selvfølgelig kan vi det. Vi laver lige en tur styrbord over og kommer op på jeres side. Jeg prøver at holde stationen så roligt som muligt.
Vær lige opmærksom på, at Sputnik sejler som en død ko i dag, fordi det ene skrov vejer mere end det andet.
Det er modtaget. Jeg har set, hvordan du slænger. Vi er i nogle autopilot lige nu, så det er lav fart og stor slængergrad. så Sputnik, jeg kommer op på din bagbordsside.
Du er placeret på min bagbordsside, det er modtaget.
Ellers så kan jeg ikke stå og styre samtidig med, at jeg ser, hvor tæt vi kommer på. Det var bare, ja, jeg kan se, at de alle sammen har fanget den. Har I fået et feedback på, hvordan den ser ud? Man kan tydeligt se, at en del af casingen er blevet trykket voldsomt ind. Den har været langt nede.
Pat, jeg synes, launch-railen, den er blevet en lille smule bøjet. Ej, undskyld, ignition mountet er blevet en lille smule bøjet. Prøv, det er noget... Jakob, blev igniteren ombord, eller forsvandt den ned på den blå hylde? Vi så mange resterende stumper, men der var ikke noget af, der var igniterskift. Så den er blevet annihileret og blevet til fiskemad? Absolut. Hold kæft, hvor ser den ud, mand. Det er jo fuldstændig kvæst. Den gjorde faktisk fuldstændig, hvad den skulle. Den krøllede først efter raketten var lettet. Jeg sagde det med godt, og det hedder med godt arbejde, dreng.
Sputnik Vostok. Vil du spørge Christian, om han vil komme ind samlet?
Ja tak, det gør jeg.
Ja, I er jo et godt sygt. Selvfølgelig følges vi med. Vi skal bare lige aftale, hvordan vi går ind, fordi jeg er jo lidt mere krævende, når jeg går an i havnen. Eventuelt så lader vi jer komme ind, og så følger jeg efter lige så snart I melder af, at I er færdige for tøjet.
Gentag signal.
Skal jeg gå først ind, så I kan ligge og holde station i havnehullet, eller skal I gå først ind? Der skal bruge ret meget plads.
Jeg spørger lige skipper igen.
Jeg lytter.
Jamen, du kan sådan set gøre, som du vil. Vi kan sagtens snige os ind, så du må godt brede dig med de store armbevægelser.
Det er meget vel. Jeg ligger sådan lidt bag jer på vejen ind, og så, når vi er ved at være der, så smutter jeg lige ind foran, og så satser vi på Antares eller lignende tegmodtrosser.
Det er modtaget.
Antares, Vostok. Antares, Vostok.
Antares her.
Antares her Vostok. Vi kommer ind i havn sammen med Sputnik, så vi er samlet. Jeg ved ikke, om I går ind lige sådan.
Vi har lige taget en hurtig beslutning. Vi går ind sammen med jer.
Så foreslår jeg, at du går ind som nummer 1 og stiller et trossehold. Og så lægger Sputnik sig i vores kølvand og lægger sig et eller andet sted i havnehullet eller i indsejlingen, mens jeg lægger til. Og så holder vi tæt kontakt lige så snart jeg har en trosse i land. Så kan Sputnik gå ind og krybe udenom mig. De er jo som en handske.
Jamen, det lyder som en ganske glimrende plan.
Det er modtaget. Sputnik, er du klar over, at du har styr på fender i vandet?
Det er et forsøg for at få den til at sejle som en knap så selvlødet ko.
Jeg tænkte nok. Jeg spekulerer på, om placeringen af hele besætningens styr på side, minus en overgænger, vil hjælpe lidt på at offsette det der lille dyrkar.
Antyder der Sputniks besætning af tunge røven?
Nej, kun, ja, der står en eller anden til højre for dig. Den hørte Mejling godt. Men jeg tænker, dyrkarret det er 830 kilo, og hvis I er 5 mand, så er I vel også en 400 kilo.
Ja, det er et forsøg værd.
Er det realistisk at flytte flaskerne, der står på forkanten også?
Nej, det er et særligt stativ, som ikke kan flyttes.
Det forstår jeg. Bolskov, André. Logistikguru, CS Logistikguru, her er Vostok. DSC RIP, her er Vostok. Her er Vostok, intet hør, slut. Sputnik Vostok, hvor stærkt går I?
Vostok lige PC 4, knop. Det synes jeg er alarmerende meget, så jeg er lige ved at tjekke, om vi vil overhede motorerne. Skifte.
Det er modtaget, slut.
Nybo, Marling.
Nybo, ja.
Er du ude på vej ud af Bornholm, når vi kommer ind?
Nybo, ja. Vil du gentage?
Gentage.
Ja, vil du gerne gentage?
Jeg kan ikke høre, hvad du siger. Jeg kunne godt lige tænke mig at få et afsluttende interview med dig, nemlig.
Okay, og hvor har vi dig henne?
Jamen, jeg er på Sputnik nu, men det er bare, vi kan bare lave det på kajen derinde. Det er bare, om du er lynhurtig på vej ud af øen igen.
Tak, nu forstår jeg. Jeg er ikke på vej ud af øen igen.
Okay, så finder vi ud af det. Vi ses.
Blå rip, Vostok. Blå rip, Vostok.
Vostok her i Sputnik. Jeg har sænket min fart til 4,2 knop på grund af motortemperatur. Og mit fintershow, det har faktisk fungeret. Nu skal jeg kun have lidt styr på over for sig lige.
Det lyder rigtig godt, bravo Zulu. Vi går stille og roligt frem foran, ja. Og så rækker vi slæb til. Du skal nok komme i land. Du skal ikke være bange.
Vi har det fint herovre. Vostok her er Sputnik. Vi har serveret aftensmaden ombord og er klar til en lang indsejling til Nexø. Det er båden sejler fantastisk, efter vi udstyrer den med en ekstra fender.
Ja, ja, vi er lige ved at arrangere grillhygge for CS Total på Kajen.
Men det lyder fantastisk. Vi tænker det ens på det punkt. Man skal fodre sin besætning.
Det skal man, når man skal pleje sin forenings succeser. Det er også bravo solo til jer på Sputnik for exceptionelt veludført arbejde.
Jamen, vi er også så tilfredse med os selv, at det er helt forfærdeligt. Og også tak til jer.
Ja, man får jo næsten... nej, den tager vi på Kajen.
Det gik jo egentlig meget godt.
Det lignede en pæn succes. Vi har fået nogle meget, meget pæne billeder af en rolig opstigning. Mikko,